Hello. 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 Can someone hear me?
Yeah, morning, sir. We can hear you.
Yeah, good morning, sir. We can hear you, sir. We can hear you, sir. Yes, we can hear you, sir. Good morning, sir.
Good morning, sir.
Hello. Can someone hear me? Hello. Can you hear me?
Yes, sir. We can hear you. Yeah, we can hear you. Good morning, sir.
Hi. Hey, hello, everybody. How you doing?
Very good, sir.
Very good, sir. Good morning, sir.
Yes. Good morning. I'm so excited, and it looks like anyone listening right now, you need to try and get a good place to sit, so that you will get comfortable. You may need to take some notes, please. So try and get that ready now before we start.
Make noise. Yeah. I'm busy. Don't need noise. Don't make noise, yeah?
I heard someone saying, please try and manage your movement. Mute yourself, please. Mute yourself. Yeah. Mute yourself. Get a notebook. You might need a calculator. Or your phone will be. Device will be good enough anyway. Yeah, it's 11 o'clock. My time here, your time there is 9 o'clock. So we're going to get started. We're still waiting for attendance here. We got 17 already on the line. So, Sam, those of you who are online now, how are you all doing? Everybody good?
Yeah, we're good. We are good, sir.
Fantastic.
Yeah, I'm good. We are good.
All right. One of the things I wanted to ensure that my audience, this course is meant for you. I would like to know more or a little about your background. I know it's a challenge because we have 17 people here, now 20. I may not be able to hear from you all, but I would appreciate a couple of you quickly before we get started. As others join us, you just tell me a little bit about yourself, probably what you're doing now, what is your inspiration, and I would say probably what do you have? Do you have any form of engineering degree, or this is just something you've been thinking about and said, okay, I want to go back to school. Let me see what engineering drilling is all about. So if you don't mind, I'm going to find a way to make it easier so that probably some of you have to pause yourself. If you raise your hand, I'm going to give you the opportunity to speak. So that we don't have it too rowdy. I will appreciate that, please, if that is fine with you all. I'm trying to see if I can get that up on my screen here, my Zoom, to make sure that I see someone who says, okay, somebody has just raised his hand. Okay, I'm going to, Ikoko Jerry, could you mute yourself? If you are Ikoko Jerry, mute yourself. Thank you very much. Okay, I see hands raised. Zoom user, you don't have your name. If you're not using your name on the Zoom, please try and put your name there. My apologies again before we started. I will introduce myself. Don't worry. My voice. I was preparing for this program, so I swallowed an elephant. So that's why my I swallowed an elephant. So my voice is a little bit blood. So, but can you hear me clearly? Is my voice a little bit well understood?
Yes, can hear you clearly.
All right. Okay, let's start with Zoom user. I don't see your name. Just briefly tell us a little bit about your background.
Ouais, débrouille-toi comme tu veux. Je te demandais quelque chose. Ça fait...
Zoom user, go ahead.
Yeah, good morning, all.
Yes, we're listening. Tell us, okay, let me repeat myself. Tell us your interest in this program. Tell us your little bit of background. Have you ventured into anything drilling before, and any educational qualification that you have that probably sets you up why you are interested, and what is kind of your plans, your thoughts about the future field of engineering drilling? Okay, he's not speaking. Let's go to Innocent quickly. Innocent. Innocent Abu.
Good morning, my name is Innocent. Can you hear me?
Yes, I can hear you.
And what inspired me to be, I did more than the last year. That was, and now there was introduction into drilling engineering, which I'm interested to go into it. So that's inspired me to be
Okay. You're a bit faint, breaking. I hope you have your communication will play up. All right. Thank you very much. Ezora.
Yeah. Good morning, sirs. Good morning, sirs.
Good morning.
Yeah, my name is Ezora. I hail in Port Harcourt, Rivers State. I study electrical electronics engineering. My aspiration is to be a qualified drilling engineer, a qualified rig engineer. That is my aspiration. That's the reason why I'm here. I hope I can get the knowledge here. Thank you, sir.
Okay, very good. Thanks. Short and sweet. Ola Phillips.
Yeah, good morning, sir. My name is Ola Jobi. I've been into bore drilling for like 7 years now. So I'd be drilling water wells. So, but I want to move on from water well to oil wells. That's why I finished with hydrology in the university. So, but I want to leave water to oil. That's the motivation.
Yeah, you want to go do the main. They call it the black gold. All right, thank you. Okudili, you want to say something? All right, Okudili is not picking up. Frank.
So sorry, I was having some hitches in my phone. Good morning, all.
Good morning.
My name is Okudili. I have a background of electrical electronics engineering. I've been on a drilling rig. I'm currently an assistant driller in a specialty drilling field, BR 301. So my interest in drilling engineering is short and simple: aspiration. I want to grow from being a rig hand to one day be a company man, because I see that is where the main thing is. Thank you.
All right. Okay. I'm sorry for the rest of the folks here. I know I would love to listen from you, but to hear from you. But let's move on. Just because of time. But if time permits, I would like. I just want to know. You know, it's always good to know those who are listening. But I think the spread needs to be a bit wide here. There are some folks who already, some of you already working on the rig as rig hands, maybe driller, I don't know, probably, or you are rustabout, roughneck, or you are a mod man somewhere there. But ultimately, these are all supports that makes that gives the opportunity for the well to be drilled and to produce. Someone said it's been drilling water well. Yes, water well is for, water well is important for drilling. Actually, you know, especially when you're on land, you need water wells to support you. On offshore rigs, the waters are hauled and supplied to the rig, barges there. So, but water well again is key. But ultimately, nobody drills or company drills water well to survive. They drill oil and gas. So it's good to learn about how that is done. Okay, I'll pull up my slide here before I just introduce myself as I do that. Again, my background is chemical petrochemical engineering. I have double masters in chemical petrochemical engineering and also masters in business administration, specializing in finance. Recently, I've been undergoing the program. I'm a doctoral candidate, especially for adult higher education and adult learning. So as adults, I understand when you want to learn something, you know, I know the issues involved. So I do have that specialization, how to manage that conversation or discussion. However, from Globat skills, the task I have before you is to give you a glimpse. Not the total package, put it this way. I want to make you to salivate. I want you to yearn for more. That is the purpose of this program. Because of timing, I want to say a lot, but as a professional, one, engineer, secondly, as someone who knows about what is finance, and thirdly, as someone who knows about people who want to learn. The learning is for you, not for me. You are the one who wants to learn. So it's going to be a student-centered approach. So I will welcome most of your questions. I know I like to talk, just to warn you, I like to talk a lot, but I've been told to limit it and let you do the talking or the questioning. And that way we can take a lot from this program. So you bear with me. Again, my voice, I joked earlier that I swallowed an elephant. That's why my voice may be very heavy. But hopefully, if you don't hear me, please just call my attention. I will repeat myself. One of the things I want also to request is, please, everybody mute yourself. We have 28 participants in the Zoom call. Mute yourself. If you want to speak, I will notify you by when I see your hands up. So questions are welcome in between the presentation. So don't worry. Our time limit, again, let me pull up the agenda here. Hopefully you can see my agenda. It's already been shared, but can you see the agenda? Everyone?
Yes, I can see it.
Okay, very good. So, introductory drilling engineering. Well, we talk about engineering. It's a big word. Most of you, some of you probably, you've gone through engineering school. Some of you haven't. And when it talks about engineering, well, you know, it depends on where you're going to attend this, your university or your school. You might spend up between 3 and 5 years. It's a lot of work. So, but please, again, I'm having a lot of background, and I beg you to mute yourself because it's going to interrupt. All right, so we're going to start off with how a well is drilled. We're going to take a break in between. Again, this is just a tentative break time. We'll go to introductory directional drilling, and then we close up with drilling rig equipment. I'm told there is another presenter who will join you guys later towards the later part of the day. Dr. Srikant, he's going to talk about the different types of rig from land to offshore and to deep, and the deepest of all. So we're going to start off with how a well is drilled. I do have some couple of videos in between to share with you. So again, I beg your indulgence to have a notebook with you. Again, there is a quiz. I know sometimes when we hear quiz, we shiver, but it's going to be a simple one. But most of the stuff I'll be talking about, listen attentively. The questions or the answers already are there. So just take note, and put it down somewhere. You may refer to it later. And I think Global Skills should be able or may share the slides with you, so for your reference purpose. So that's something you will have to discuss with them. There is a quiz. I think we'll find a way to get that quiz to you, probably not immediately after the course, but you will get it probably from email from Global Skills, and they're going to use that for the testing and then for your certification. So let's go right away. It's just 14 minutes gone, so let's see how we can kick off here. So I do have a couple of slides. I'll be tumbling from one slide to the other, so bear with me as we do that. So this is the agenda, and now I'm going to go see if I can pull out of here. Okay, let's get to my folder. Okay. All right, come on. All right, so how to drill a well. Now, initially I talked about us engineering. When we talk about engineering, one of the fundamental in engineering is what? Can somebody tell me what is, when you hear engineering, what is the most, what differentiates engineering from other courses or programs you've heard of? What is the key engineering when you hear engineering? Can somebody tell me that?
I can say innovation.
Yeah, innovation. Yes, innovation. Very good. Yes, innovation. Actually, what I know you're trying to make it a little bit complex. I'll try to make it simple for you. Engineering is calculation. Anytime you hear engineering, you must calculate something. There's something you have, numbers, put it this way, numbers. Numbers always involve engineering. And when you mix up your numbers, things go wrong. You can imagine somebody who is trying to build, let's use engineering, drilling itself. You're asked to pump cement, and probably you're asked to pump, 70 barrels of cement, and you calculated, and then you went and said, your calculation gave you 20 barrels. You pump 20 barrels and you think you're done, and your casing is not cemented. That is a disaster. That means top of your casing is all exposed to the reservoir, and that could lead to dangerous consequences. So numbers are very important. And this slide I'm showing you here is not by accident. I'm bringing it to your attention because this looks like what we call, if you recall, most of you, especially back home who studied, I'm sure it's the global mathematical formula. You call it the almighty formula. You remember that when you were in school, or the almighty formula. I want to say this is the almighty formula, which is pressure equals rho GH. Pressure equals
Hello,
rho.
sir.
Yes.
Hello. Yeah, they can't see your slide, sir.
Oh, you can't see. Oh my goodness, sorry. Thought I'm sharing this. Let's see. Sorry about that. Where's my folder? You can see the slide? Are you the only one?
Yes.
Anyone else?
We are seeing the folder.
They are seeing the folder, not the slide, not your slide. So you need to share the slide. You need to move the screen to the slide. The share screen to the slide so they can see it.
Share screen to the slide. What have I done here? Let's see. See if I can correct this. Correct this. You can see this folder, right? You can see my folder?
Yes, we can see the folder.
Yes, sir. You can see folder.
Okay, you can see this folder. You can see this folder. Okay, I'm going to click. Can you see? Hello?
You're sharing the folder. You're supposed to be sharing the screen. When you click, you're supposed to be sharing the screen.
Yeah. Okay. I think this
or
is
the
probably,
image you want them to see.
Okay, I think this probably. Let's see. This help. Does this help? But we got the agenda. The agenda was, you were able to get the agenda. So, what is this? You are screen sharing. Okay. Let's say stop sharing. Let's go back. Okay, you can see my folder. You can now see your screen. Okay, you can see my screen. Go here. What about this? Hello?
Yes, we can see that. You can see an image now.
Okay, that is P equals rho GH. Can you see that, everyone?
Yes, we can see that.
Okay, sorry. I know this is some few stuff here, but hopefully we'll get through this. Thanks for the help. Please call my attention, please, anytime you feel like something I'm saying is not appearing or looks odd. Okay, so now, so as I was talking about this formula is key because especially when we're drilling, it is important for us to be able to manage the zone we are penetrating, because when we know the deeper you go, the higher the anticipated pressure. Anticipated, of course, it's not always the case, especially when we're talking about drilling here. For some of you who have that experience or who have heard about it, there are times you get to a place where you have total losses. Total losses. What I mean by that is you are drilling a hole and suddenly the mud you have inside the hole is going south. You're losing it. You're not seeing it coming back to surface. Few things are going on there. The reservoir or the formation you are drilling is very weak, not able to sustain the mud, the hydrostatic pressure acting downwards, and the pressure of the reservoir is lower. So that brings me to introduce you to some three common terms. Take note of this, please. Common terms. Generally in drilling, we could have three scenarios. One of them is under balance drilling. We could go under balance drilling. What it means is under balance means your formation, as I said, the deeper you go, it is anticipated that the overburden increases. Overburden means the weight, amount of weight that is acting on that layer of your formation below the ground. You're talking about subsurface now. The pressure there is higher than the mud that is the mud you're putting in the hole to be able to take you to where you want to go. So that is called under balance drilling. So under balance drilling means the hydrostatic pressure is less than the reservoir pressure or the formation pressure. Please take note that I did address the concern that you should have a notebook with you, please. Please, I hope you're taking note. We have underbalance drilling, where the hydrostatic pressure, that is the weight of the mud acting downward towards the formation of the reservoir, is less than the reservoir pressure. That is called underbalance drilling. Secondly, you could have another scenario where you have what is called managed pressure drilling. Managed pressure drilling. This is when consciously we want to make sure that our hydrostatic pressure, the weight of the mud acting downwards on the formation, equals the formation or reservoir pressure. And thirdly, is what, if you don't hear any specialized name, we call it conventional drilling. Conventional drilling. This is generally what most times we do. Meaning you drill, your weight of your fluid is the weight of your fluid, the pressure is greater than the formation or the reservoir pressure. So I've just listed 3 scenarios in which in anywhere, any part of the world you could see happening. 1, conventional, meaning your hydrostatic pressure acting on the formation is greater than your reservoir pressure. 2, you could have underbalance drilling, where the hydrostatic pressure, because of the fluid or whatever means you are using to stain and to clean up your wellbore, is less than the reservoir pressure, that's underbalance. And then you have managed pressure drilling or balance drilling, where you try as much as possible to stay within the margin where your hydrostatic pressure equals your reservoir or formation pressure. Again, each of these scenarios has their utilization. It's not going to be covered in this program, but it is important for you to be aware of them. All right, now let's go back to this formula again. This formula talks about pressure. Now, we have in the oil field, we have 2 types of units, particularly 2 types of units, depending on where you are, North America or Middle East or Africa. Mostly, I'm going to speak generally. Generally, in North America, we use what we call the SI unit, kilogram meters, okay? In Middle East and Africa, we use what is called the imperial. We talk most time about feet, inches. In North America, I talk about volume. In volume, talk about gallons. In the Middle East, Africa, I talk about barrels. Talk about barrels per foot at capacity. Then you could talk about gallons per meter, or gallons per centimeter, gallons per millimeter. Length, talk about length in North America. In SI, I go to millimeter. In Middle East, Africa, talk about feet and inches. So your pipe length. So I'm going to be, if I do mention unit, I will be basing my conversation on Africa and Middle East. So if I say length, what is the length of my pipe? Expect me to say in footage. I want to say, what is the diameter of my pipe? Expect me to say in inches. If I want to say volume, I want to mention barrels. And I want to mention pressure. I would like to use the word PSI, pounds per square inch. If you go to North America, it becomes megapascal. So these are conventions, and conversions, which you'll be familiar with depending on where you are working. Again, this is ahead of time. All right, let's move on. I'm just giving you some introductory notes here before we move on. I need to share with you another slide. Again, there are some piecemeal slide here I want to put up just before we get into the big slide to share with you. Okay, so we have to go back again to my screen. Where is that? Okay. All right, I think I hit this last time. Is that the one I hit? Okay, how to do it well. All right, materials. Okay, now let's quickly take a look at one simple calculation here, because I love calculations. as an engineer, this is the bread and butter of what we do. So let's take a look at this. Okay, can you see my slide? Can you see my slide, guys?
No, can't see it, sir.
Sorry. You see the slide?
Okay, it's better now.
Okay, pull up this. What about this?
Yes, you can see it.
Okay, now let's go back to that formula. Remember that formula I showed you, which is P equals rho GH. That formula is pressure, right? It is hydrostatic pressure. So I'm giving you a scenario now. This is a question. The question said the mud weight. Now, in that formula, when we wrote rho GH, rho stands for the density, which is, again, going to be pounds per gallon. That is the unit. Mostly we use in Africa and Middle East. If you go to North America, that unit changes. So the weight of the mud, we'll be talking about mud later. The weight of the mud is in pounds per gallon. Now there is a constant there, that rho, remember rho GH. You talk about G as acceleration due to gravity, but because of the conversion, we call it here PSI per foot. Okay, that is the gradient. And then you have your vertical depth. This is very important, ladies and gentlemen. I don't think we have any ladies in the house, except someone can call me. If you're a lady in the house, call my attention. Now, it is very important that when we are dealing with anything related to pressure, this is very important, gentlemen, take note. Anytime you are drilling a well and you have anything to do with pressure and temperature, there are two types of depths that are measured while drilling. There's what we call TVD and MD. You want to take a note of that. TVD means true vertical depth. True vertical depth. And we have what the second one is measured depth, MD. MD, measured depth. Anytime you are doing any form of calculation that has to do with temperature, you're finding the gradient, you're finding the pressure, you use TVD. TVD. Whenever you are talking about capacity, okay, capacity, which is volume. Imagine you have dug a hole that is 10,000 feet long. You want to know what is the size of that hole. You use measure depth. Measure depth. Okay. There's a correction on take note. There's a correction on that gradient there. It is 0.052. It's been corrected at the below point there of the formula. So let's go ahead. As you can see, the formula said, the formula, can somebody remind me of the formula for calculating the pressure?
Rho GH.
Okay, all right. So let's go ahead. Now, take a note, there's a correction on this slide. I want to just catch your attention. Gradient. The gradient there is 0.052, okay? Not 0.52. There's a 0 in front of the 5. Please take note of that. All right, so if you plug it in, did everyone arrive to this answer? Did anyone arrive to this answer? Plug it in, 0.052 times the mud weight. The mud weight is 10 times TVD.
Yes, sir. Yes, sir.
Yes, 3,120. 3,120, that's the PSI. So that is the correct answer. Again, take note, that gradient there is 0.052. Okay, all right, that's good. So please remember this formula. Remember this is something you may come across in your quiz. All right. Okay, let me put one more last one before I take you to something else. Okay, we've done this already. Let's look at something else. Okay, 1, 2. Okay, now this is what I'm talking about here. You can see my slide. You can see my slide. Hello, I need response. Can you see my slide?
Yes,
okay,
yes, we can see it. Go ahead,
yes.
sir.
All right, so this is just again reminding you about the true vertical depth. Okay, the true vertical depth is that perpendicular line from your surface, from the surface of where your rig is standing. That line that goes straight is your perpendicular line across the ground, perpendicular. So that is what we call true vertical depth. And of course, you have your mud inside the hole, and then that calculates your hydrostatic pressure. Okay, one more slide here. I want to share it with you. Okay, now this is interesting one. I hope you can see this slide. There are 2 wells here. There are 2 wells here. One of the things you notice, let's look at well number 1. Well number 1. You can see that well number 1 drilled into a green zone. Now, in oil field, we typically try to use color to differentiate what we are seeing. In the oil field, we have gas, we have water, we have oil. Which of these 3 substances should be on the? Which of these 3 substances will be the one shallower? Can somebody tell me? Oil, water, gas.
It's gas.
Yes, correct. Thank you very much. Gas will always try to find its way to the surface. So on this diagram you're looking at, the red represents gas and the green represents oil. Okay, the water layer is not visible here, just for presentation purpose. Now, one other thing we do in drilling a well is we want to understand what is the formation pressure, what is the reservoir pressure. When I say reservoir, this is very important, and we don't want to mix it up with formation. You know, there are different types of formation you drill. Different types of formation. You can drill into shale, sandstone, limestone, carbonate. You can even drill into a salt. But at the end of the day, there are special zones that do produce. If a zone produces oil, we call it a reservoir. Any zone that produces hydrocarbon, we call it a reservoir. So not all zones are reservoir. Just have that in mind, okay? Reservoir means it has embedded in it hydrocarbons in the pore space, and it has permeability. They can flow. As long as it can flow, it has the potential for it to be called a reservoir. The second question is that volume enough, sufficient enough to say, yes, we can make it economical? That is a different question for the economics and the financial, the CFO to decide that. All right. Now, in this diagram, let's look at well number 1. Well number 1, you can see that these wells, the lines are straight, but don't get confused again. This is just for representative purpose. The straight line doesn't mean the well is a straight well. We'll come back later to talk about directional drilling. This well, as it portrays, it tells me something, because if you look at the depth, let's look at well number 1. Can somebody tell me what is the well depth?
6,500
feet. 6,500 feet.
6,500 feet.
Yes. And
6,000.
And 6,000 vertical depth.
Okay, you are there's something I'm not hearing you tell me. Measure depth, TVD. Can you see that? Very
measurement.
important.
Yes, very okay. Yes.
Very important to take note of. Whenever you're again, engineering is very important. Numbers are important. Units are important. So, because at the end of the day, if we mistakenly use this one for the other, our result is wrong, and it could lead to catastrophe. Because at the end of the day, this will help you to determine the mud weight you want to put in the well, the mud weight in pounds per gallon. So let's look at well number one. Well number one tells me that the measured depth is 6,500 feet. The TVD is 6,000. So that means this well is inclined. This well is not vertical, okay? It is not a straight well. When those two numbers are not the same, it means the well is not vertical. It means it is inclined. We'll talk about that later on, directional drilling, inclined. So either it's 10 degrees, 15 degrees, 20 degrees. Again, that's something we can work on to be precise. Now, we want to find out, the question here is, what is the formation pressure of this reservoir? What is the formation pressure of this reservoir? There's one important information you have been given. You've been given the pressure gradient, 0.52. Hello?
0.52 psi per feet.
Per foot. Okay, yeah. So we got, excuse me, we got the gradient. Gradient again is the pressure over the depth. Now, I want to find the pressure. I know the pressure over the depth, and I'm given the depth. So, anyone have an idea how I can get the pressure for one? What should I do?
You multiply the pressure gradients with the TVD.
Absolutely. Who is that talking, Mr.
Lucky.
Okay, Lucky. Thank you very much. Absolutely. So please take note of that. You take the TVD. Remember, I said anytime you are calculating pressure or temperature, you use TVD. So let's do that. And what are you guys getting? What is the pressure of the reservoir?
3,120
3,120 psi. Don't forget, always
psi.
Correct. Okay, everybody good? All right, today you good? All right. Okay. Any question on that? Let's move on. Okay, let's quickly do the second one. The second one is the second well. The second well now also drills into a gas reservoir. The pressure gradient has been given to be 0.2 psi per foot. Is that well vertical or directional? Can somebody tell me the one?
It's directional.
Yes,
Directional.
How do you know it's directional? How do you know?
Because the MD is not equal to VD.
That's correct. Very correct. Okay. All right. Okay, so somebody give me quickly, what is the formation pressure or the reservoir pressure of that gas zone? What do you got?
480 psi. 480 psi.
480 psi.
That's correct, 480 psi. So you can see that, yeah, that probably is a shallow well again. You know, not much less of a body. Please, somebody please mute yourself. I beg you. Mute yourself. All right. Okay, let me just put this one more slide here. So this is what we're talking about: measured depth and true vertical depth. You can see this well. It drills from a rig, and you can see the right side, the curve. Of course, it's clear that the curve is longer than the vertical line. So measured depth always is greater than true vertical depth. So if you are given two numbers and you are confused which is which, you should not be. You should not be. The measured depth always is either equal or greater than.
Daddy, how are you?
Frank, mute yourself, please. Mute yourself. Okay. All right. Okay. Now, I think we talked too much about calculation here. I need to take you now to the presentation on drilling well on land. There's one more thing I wanted to share with you here. Let's see if I can pull this out. Okay, before I come to this, let's go back here. Just where is that? Okay, now, before we drill well on land, we talk about the formulas already. It's very important for us to understand what are the things that you need to drill a well. Now, I'm told Dr. Srikat will be taking you on drilling rigs. So he's going to talk about land rigs. offshore rigs and semi-submersible and all the rest. So for simplicity's sake, I'm going to dwell mostly on land rig. Share with you land rig. Again, my experience across the board. I've drilled Jacobs, West Africa. I've drilled land in Western Canada, Middle East. I'm drilling on land. So offshore Jacob rigs, I have those experience. But for simplicity's sake, not to make it too complex, let me just try and don't jump into Mr. Dr. Srikat's material. Hopefully you get enough from him. So I'm going to speak generally land drilling. Of course, this is not swamp drilling. It's much easier because you have access. One of the opportunity of land drilling is you have easy access to materials. And in terms of when there is the uncontrolled release of hydrocarbon, something like a blowout, or well controlled, yeah, you can manage it easily because you have logistics, not a big problem. Yeah, you may have to travel some distances, but it's better than you taking a boat or bringing a chopper somewhere to come and land on a rig or bringing personnel. It's much easier. So let's, before I go to the presentation, I want to introduce you to some of the key materials, some of the key basic drilling materials you need to drill a well. So I'll be briefly here. Now, to drill a well is not only done by one person. Operators, either whatever you call them, Chevron, ExxonMobil, Total, Totafina F or whatever, all these operators, Aramco, what do you call them, all the big operators, they don't have, how would I say, they have the capacity to provide everything, but for economic purpose, there are some activities of materials they allow the service providers to make available to them, for them to manage, because you become jack of all trade and become master of none. You need to know where your strengths are. So I'm going to speak in general terms here. So list of materials. Typically, for you to drill a well, the operators typically, they supply the casing, which is what you put in the well to secure the wellbore. Okay, of course, they have to buy it from a supplier who manufacture it to their spec, but generally the operators own the casing. Wellheads are owned by the operators. Again, they are supplied by service companies, either FMC or Vetco, whatever, but they own it. And then the Christmas tree, where you not tie to your production, these are owned by the operators. Bits is a bit contagious here because it depends again. Some operators like to buy the bits from the vendors and own it. But some says, no, I'm going to rent it. So it can go either way, renting or buying. Again, the economics at the end of the day is what matters. We have also the people we call the service companies. And what do they do? Typically, they provide you the materials to ensure your well is secured. Cement, mud, bottom hole assembly. We'll talk about this later when we start doing directional drilling. And these are specialized components like motors, MWDs, steerable assemblies, well-controlled equipment. Some service company, when they bring the equipment, depending on the condition of the well, they have their own well-controlled equipment to make sure that their tools are not, when it gets stuck and the well is flowing, they're able to secure the well. And then, of course, we have well-controlled equipment. Well-controlled equipment, these are specialized equipment, which the rig brings it with it. It comes with the rig. And of course, the rig, the biggest equipment, which no one should miss, is the rig. These are rig contractors. Again, some operators own rigs. They buy the rigs and they want to keep it. But typically, the operators tend to hire the rigs for a particular period of years or timeline, and after which they release it. Again, this is all about economics. Bottom hole assembly also. The rigs do also come with certain bottom hole assemblies like heavyweight drill pipe, drill collars, jars, and all the other accessories. Now, one of the important thing, one of the things I did mention here is that when you drill a well, depending on how the outcome looks like after you drill, you got your target zone and you've logged the well, you've seen what it is it a reservoir? That's the question always at the end of the day, we want to get a reservoir. We need a reservoir that can produce. If we found a reservoir and it is promising, then we go to the next stage. And that next stage is either you want to go cut core from it, log it, and the result will tell you whether to go and complete. So this presentation doesn't cover completion. Again, it's not part of the class. It's something else. Probably if you guys request for, Global Skill can arrange that. Completion. In that stage, entire ball game. You need more additional equipment or materials such as the production tubing. You may need some packers, and then the service company might come in with some chargers, perforation guns, and do other lots of stuff in the well to ensure that you know what you are producing and whether you want to put it to production and whether it is economical. Okay. All right, I'm going to move away from this slide just to give you a heads up here. Let's go back again. Let's see what we got here. All right, so we'll talk about materials. Now let's go to drill a well. This is the main slide I've been presented by Global Scale to share with you. Oh, somebody have your hands up. Yeah, go ahead, Olatunji.
I want to ask that, can we have the presentation slide after the class?
Sorry, I didn't get the question. You said?
Like, can we have the slide after the class and the recording session?
You want me to repeat the slide?
Yes, sir.
What is the heading of that slide? The last one I just closed?
No, like this presentation, the material you are using, are you going to give us after the class?
Okay. I think that question will go to Global Scale. I believe they will do that, yes. I will make sure that everything here gets to them and you guys have it so that you can, hopefully you will take the test and then you ask for certificate. No problem. All right. Let's go now to the presentation. I know we spend much time already here. I'm supposed to switch over, but it's all good. It's all good. I'll manage the time here. Okay, how to drill a well. This one is going to be quick. All right, so you can see this. You can see my slide, everybody.
Yes, sir.
Yes, sir. We can see.
All right. How a well is drilled on land? Again, remember I talked about land. Again, it's unfortunately that land is a simple case, but you can ask questions to Dr. Shrikant for offshore if time permits. But let's go ahead. So now, as you notice, even some of you where you are right now, depending on where you are living, if you come out of your house or you just look at outside your window, you notice that if you can see the ground, you notice that it's very, very rough, sandy, and maybe some grass is growing, or you might see some rumples all over here, hills, Yeah, typically, this is what we have on the land, on the land drilling. You want to drill a well. First and foremost, the geologists. Again, I did not mention some of the participants that makes a well happen. Akpati, please. Akpati, mute yourself, please. Akpati, please. Akpati, Chinema, mute yourself, please. Okay. Now, before we start to drill a well, one of the things that happens is the geologists, the petrophysicists, all the participants involved, we call them the asset team. They have to assess where they want to drill. And it requires doing some seismic activities. Sometimes we have 2D technology advanced, now we have 3D and even 4D. They assess the region to see where it is the sweet spot due to they use some sound, they send some sound waves from the surface to the subsurface, and they get a reflection, and it tells them what is downhole. Not precise, but it gives them an idea. And this is very important, gentlemen. There is no way anyone can tell you that there's hydrocarbon in a particular place unless a well is drilled. The only way you can precisely say there is hydrocarbon or there is reservoir below the subsurface of any part of a region you choose is only by drilling. You have to drill it. There's no magic wand. So now we want to drill. One of the challenges of drilling a well is because we have Population growth. Population growth. Land is becoming scarce. There is always a challenge to say, where is the best place to drill a well if really there is hydrocarbon? I need to say this before we start to drill a well. Very important. If you're writing down, take note of this. The most important thing before drilling a well is safety. Safety. What are the safety concerns? The health of the people around the region you are drilling and the people working. Health. Their health is important. Whatever activity you're going to do, they have to be protected. Number two, the environment. The environment is important. We don't want to drill. The purpose of drilling, you produce oil and gas, and the land is polluted, animals are killed or animals died, people are sick. No, that's not the goal. And thirdly, I said health, environment, and safety. Safety. You need to protect the people from whatever means, whatever you're doing, you need to protect them safety-wise. And now we add security also. Security is one of the elements that have been added. Security, you want to protect them because we have, again, especially West Africa, pirates and the rest, all those stuff. People must be protected. So this component is always added when you're planning a well to drill. Now let's talk about safety. Let's talk about environment. Water. Where do we get water from? It's from the ground. So if water is coming from the ground and you want to drill a well, you want to isolate that zone where the water suspectedly is being produced so that people don't drink water and they're drinking hydrocarbon. Very important. So typically, depending on where you are, North America, if you're onshore, it is very, very key because most times you have living quarters. You have people living very close by. In North America, it's a big deal. If you're offshore, okay, offshore, you are way, way off the land. Yeah, that might not be a problem. But on land, the groundwater is very important. You have to protect it. All right. Typically, the first thing you do when you want to drill on land is you want to make sure that you drill a cellar. A cellar. What is a cellar? A cellar is just a compartment that allows you to install your wellhead. So because the wellhead sits on the wellhead sits on the casing. So you have to make sure that you have it's a big size equipment. So the cellar has to have some dimension. So that's the picture you're seeing here. So on land, majority of well begins with digging a cellar 3 to 15 feet in depth. Again, depending on where you are. Above the cellar or your wellhead comes your Christmas tree. So that is why it is important that is done. Next, you run a conductor pipe. So you have a cellar to have access to your wellhead because the wellhead comes with valves. When you go inside, you should be able to step in to close your valve, to open your valve. That's what the cellar is for. But after that, you have your conductor pipe. The first string of pipe used in a well is called a conductor pipe. Again, depending on offshore, onshore, it might be driven, it might be drilled and run in hole and cemented. The size could vary, 30 to 36 inches. Sometimes it could be up to 42 inches. It could be bigger depending on where you are. And depending on how deep your well is, the conductor pipe size will be determined. All right, let's move on. Next. Now, one of the things in drilling in any location, there is a concern that, as I said, safety, environment. There's what we call shallow gas hazard. Shallow gas hazard. There are some parts of the world where if you just dig the ground, you sense that you will be smelling hydrocarbon like methane, propane, ethane. So those gases are dangerous. Of course, you know, they have their flammable limit. Flammable limit, meaning you bring them in contact with any ignition, it's going to cause explosion. So first thing we do is they do a test around the region to make sure that there is no hazard associated with shallow gas. And most times, for us to prevent that, we need to have what is called a BOP. What is a BOP? A blowout preventer system. These systems are graded depending if we know the pressure, anticipated pressure coming from the subsurface. There could be up to 15,000 PSI rating, 10,000 PSI, 3,000 PSI, 500 PSI, 300 PSI. So depending on the formation, the anticipated release of hydrocarbon, the pressure, remember again, pressure, rho GH, the size of the BOP are determined and selected. So it comes with flanges, it's welded to the conductor pipe and connected to the diverter system. Now, there's a term we call diverter system. A diverter system is a form of BOP. It's not a BOP, but it's a form of BOP which does not close. You don't close it because it's designed to allow the well at that shallow depth to flow out, to let it go. Because if you close it, you won't be able to handle it, and it won't be safe for the personnel on the rig. All right, how a well is drilled. Let's continue running the surface casing. So, can somebody remind me so far? How many casing have we run so far?
One, sir. One, conductor casing.
Okay, we call it conductor pipe, okay, not casing, right? Very important. That's a very important statement you made there. And thank you for saying it. You need to correct it. It's called conductor pipe. After the conductor pipe, you now have your next casing, okay? Surface, I call it, okay. I know the slide is a bit, how will I put it? Some terminology I need to correct. Pipe, overall, pipe. Pipe is anything made of metal. Yeah, pipe. But typically, we try to be very specific. So we say conductor pipe, and then we have our surface casing. Okay, surface pipe, surface casing. But again, you get a pass. We call it surface casing, okay? Surface casing. So conductor pipe, surface casing. Now, what is the surface casing? The hole is drilled for the well for the first string of pipe, the surface pipe. The pipe is running hole. There may be several strings of pipe in the well, each run to different depth. Now, one of the determinants of where you have to set your pipe or your casing, one of the things that determine where you set your pipe, I don't know if someone can just see if you can tell me that. What do you think? What determines how far you can push your casing or drill the hole to set the next casing? What determines that?
To me, I think it's the point you have a point of no refusal, where you have cannot go again. You stop there.
Okay. Yes, point of no refusal. Well, no refusal. I can push myself. For each person, he has his own no refusal point. So who's going to win? Yes, that's a good thought. Anyone else?
I think also study that determines the type of casing to be used at the particular point.
My question is.
I would say the type of formation.
Okay, that's a good start there. Formation, yes, formation. You have a formation you want to cover. You want to cover a particular formation. Let's remind ourselves again. What is that almighty formula I talk about? What is that formula calculating?
Hello?
Yes, what is that almighty formula I gave us in the beginning?
P equals rho GH.
And what is P? What is P?
Pressure.
It is the pressure that determines how far you can push your next casing point or how far you can drill. Remember, I said different formations have different pressure over body. As you continue to drill, you get to a point where you get to hit a high pressure and you cannot handle it anymore. Your well, instead of drilling conventional, you might be drilling under balance. And if you don't want to drill on the balance, you have to stop because the well will want to flow on you. So very important. What determines it? Two things. I think some of you mentioned. You talk about pressure and you talk about the formation. If I have a formation which is very, very troublesome, I want to quickly seal it up. I want to seal it up. That's where I call my casing point. Or if I notice that if I cross that formation, the pressure is going to rise, I want to seal it up before going to the next zone. All right. Thank you very much. Okay, that's it. I see people making marks on my screen here. Please don't do that. All right. And again, we talked about fresh water, right? Remember I said fresh water zone, salt water zone. Sometimes we want to seal this behind us because we don't want to expose it. If we expose it and we drill, sometimes it could lead to the fact that when the well is flowing, you can have broaching. And when you have broaching, it starts coming to the surface, it could cause havoc to the environment. All right, so we have conductor, the next pipe now, conductor, cutting the conductor and pipe to surface. Now, you know your pipe itself, typically your pipe, your casing comes in different ranges. There's range 1, range 2, range 3. The length of the pipe typically comes in 40 feet, 36 feet, 39, and in between. So typically we use standards. We have standard length of pipe. So when you run your casing, at the end of the day, the casing comes to surface. You need to cut it. To cut it in line with your wellhead. So that's what we do. So you cut it off, you cut it, and you cut it very well to make sure the height aligns with your wellhead and the ground level. Remember, we have that cellar, right? I told you about the cellar. And you can see from this diagram, you can see the yellow drawings there. Those are the valves. Those valves seals up at the end of the casing. Who's talking there, please? Please mute yourself. Lucky, please, can you mute yourself? Thank you. Okay. All right, so you cut it off. Why do you cut it off? You cut it off to dress it so that it can align itself with the ground level and your wellhead. Okay. All right, the next one, installing the casing head and housing base. Now, because you have your pipe on the ground, something has to fit on it to make sure that you have a stability. And that's why we have the base plate. There's a base plate. It is typically welded on your conductor pipe. It's welded there so that because you're going to put a lot of other heavy loads on it. So you need that solid base. So you have the base plate. And the base plate, above it, you're going to see the subsequent wellheads added. As you can see the next diagram, now we've added the base plate because we said this well has some reservoir and their pressure, we need a BOP. So that's why I see the red diagram, it signifies the BOP, and the base plate there you can see with the casing head. So the first wellhead, we call it the first head that is installed on the base plate is called the casing head. It's called the casing head. It allows you to install your BOP. Again, we talked about the BOP, right? The BOP, there are different sizes, different rating. Again, depending on the well itself, means what size you're going to nipple up. Call it nipple up, means which one you're going to install. And then we have installing what we call the casing head wear bushing. Wear bushing. This is a term very common when you are drilling because you have your pipe going downhole. We'll talk about that later when we talk about directional drilling. Your pipe is rotating, your bit is rotating. You want to protect this sophisticated equipment, this wellhead. So they put what is called wear bushing because each time you're going in and out with your pipe, you have metal to metal surface. The wear bushing tends to protect that fine surface so that you don't have erosion. And if you have erosion or wear, at the end of the day, your well is finished. You can see some leakage, pressure rising at the annulus. All right, how to drill a well. Step 10, installing the intermediate string. Now, we've talked about conductor pipe. We talk about the surface casing. We also have what they call intermediate string or intermediate casing. Again, string just means something lengthy, long, but casing, okay, intermediate casing. Intermediate casing, again, depending on how deep, where is your target zone? Your intermediate casing, number of intermediate casing could be 3, 4, 5. So that's what you see here. So it's just telling us that A hole is drilled for the intermediate casing, and the casing is thrown in the hole and cemented in place. Now, can somebody remind me again, what determines how far I can push my intermediate casing?
The pressure.
Pressure and formation.
The player.
That's
The type
correct.
of formation.
Yes, depending on the pressure, if I'm going to hit a very high pressure zone again, I need to quickly retrieve, stop, and then make a change, run the casing and set it. Again. Secondly, it depends on the formation I want to seal up. Is there a shell zone I don't want to be exposed on my next zone, or is there a what do you call it, a salt zone which is kind of troublesome I want to seal, or is there a lost circulation zone I want to make sure I put it behind me? So again, formation determines where I need to stop drilling so I can set my casing and cement it. Very good, very good. Okay. Next, installing the casing hanger and casing head again. So we talk about the casing head. We talk about the casing hanger. The hanger is what is a hanger? A hanger is just like something holding the pipe. So when we run the casing at the end of the day needs to sit on the casing head. Okay, so it comes with a hanger which has some grooves so that when it goes down, it sits and it lands properly. And these are the job of the service providers. They are expert in making sure that this is done properly. And sometimes if it is not centered, it could lead to problem later on because you have what you call broaching, and that seal is important because they have some sealing elements, O-rings that tends to very high pressurized O-rings that can withstand high pressure. If the hanger is not properly seated and those O-rings are damaged, and this well you start to produce heat due to heat and temperature, you could have hydrocarbon or you could have gases leaking. So this is very important. That's why you have the hanger, casing hanger. Casing hanger goes with the casing into the casing spool. The spool is the area where it sits in. All right, installing the BOP. Okay, next, of course, after each whole section, you nipple up before you put your casing hanger. You put your casing hanger. You run your casing and you land it. You nipple down the BOP. You nipple down the BOP and nipple up the casing head, because remember the last one. If we go back 2 steps here, we had only one. Look at the green. Let's look at the green. You see one green, the casing head. The casing head. Now we go to the next diagram. You see there are 2 now, right? So after each one, a BOP sits on it. After each one, there's a BOP. We call that nippling down the BOP. So you put the BOP aside, you put in the casing head that you put on the well head. After that, you put back again the BOP and you continue to drill further. So that's what is happening here. Now, this one we are running the production casing. So as I said, conductor, the first pipe again is, the first pipe running the hole is what? Please remind me.
Conductor pipe.
The next one. After that, what comes next? Surface casing. And then what comes next?
Intermediate casing.
Yes, intermediate casing. And we said, somebody's hammering something. Is somebody drilling behind us here? It's practicing already. All right, we have intermediate casing. Intermediate casing again could be more than one string. It could be more than one, depending on how deep the well is. It could be more than one. So after the intermediate, now we get to the production casing. I think the next slide probably talks about, but let me say it here. There's what we call production casing and we call production liner. Okay, these are 2 different things. Take note of it. It may come out in your test. The difference between a production casing and a production liner is that a production casing is run to surface. Production casing, when you drill the well to the depth, anticipated depth, you run it all the way to surface to land on the wellhead. While a production liner doesn't come to surface, you hang it inside the last casing with an overlap. Again, the overlap could be somewhere between 300, 500 feet. Okay, those are the difference between a production casing and a production liner. Again, of course, the next question is, why do I need to run a production liner? Why not run a casing? The reason for running sometimes production liner is because if you run it as a casing, you will have too much surge. Surge means too much we call it pressure on the formation, which could lead to lost circulation, could lead to breakdown of certain weak zones. That is why you run a production liner. Otherwise, you run a production casing. I hope you capture that. Production casing is a full string that is run from bottom to surface. A production liner is a string that is suspended on the last casing that is run, typically with an overlap of 500 feet, to avoid causing potential downhole issues such as surging, which could lead to lost circulation. Of course, at any stage of this casing, after you run them to bottom, on your target depth, you have to cement it. And what is the purpose of cementing? Of course, cementing is to ensure that you isolate your reservoir or your potential zones. Cementing is very important. You isolate those trouble zones. Very good cement job is important. There are so many things that in drilling a well we take for granted, but it is important to know that cementing is one of the key important ones. We don't know it until something happens. If you don't cement your casing very well and you do a bad cement job, it could lead to broaching. Your formation, the formation you're trying to isolate will start to come in. And when it starts to come in, you have what's called channeling. And when it starts channeling, it finds its way all to the surface, to the wellhead. And you start to see pressure on your wellhead. And when you see pressure on your wellhead, you want to bleed it off. And when you try to bleed it off, you can't bleed it properly. That well can be abandoned. You suspend the well. And that is loss of revenue. All right, so you run the casing. Of course, you have with the hanger. And you put your BOP, the next BOP on it. Now, the next one now is running the production tubing. All right, the well has been drilled. All the casing has been run, cemented. Everything is good. Before we run the production tubing, there's one condition must be met. What is that? Who can tell me? Why would I want to run production tubing? What must have happened?
It has been ascertained that there's hydrocarbon in the well.
Absolutely lucky you said it well, and Mr. Sam, thank you. Yes, the drilling team or the operator has ascertained and confirmed that this well is a good well to produce. Otherwise, this is an additional cost. Running a production tubing when there's nothing to flow to surface. Why would you want to do that? It is because they have figured it out that the production is sufficient or is economical enough to meet the expenses or the cost of the well. Yeah. All right, we're almost there. Again, this is now going to completions. We're not covering completions, so I think I will just wrap it up here. And that is it, how well is drilled. Yeah, the Christmas tree again, as Lucky was just talking about. If the well is good, we put a Christmas tree. You can see the wing valve. You can see the flanges. You can see all the valves connected there. Master valve and the rest, wing valve and the choke. Means you can connect it to production and you start to flow the well after you have done your well testing. Okay, we spent so much time, I know. Wow, my goodness. It looks like there's going to be, we're going to take a quick break here. Let's take a quick break, 5 minutes break. Let's come back. Let's stay put. Of course, you're not going too far. Let me give a 5 minutes break. We'll start 10:20 here. 10:20, we continue to our second slide. I'm going to be fast then because I've spent more than anticipated time here already. Okay, is that fine?
Yeah, that's cool.
Yes, it's fine. Yeah. It's fine.
Okay, let's take 5 minutes. 5 minutes, except if anyone wants to talk to me, take a break, feel free. 5 minutes, let's chat. If you want to chat with me, I can take your questions. I'm good. But 5 minutes time, we kick off to the next presentation.
Hello.
Yes, go ahead.
Okay, please, I wanted to throw a little more light on the difference between the running completion tubing and a casing to the surface. So I really want to get the purpose, the major difference. Why sometimes we run tubing and hang it on the last casing, why some other time we run the completion casing straight to the surface.
We don't call it completion casing. You mean production casing and liner?
Sorry. Yes, production casing and liner. Sorry.
Okay. Yeah. So one other big reason for that is all about cost. Anything we do in the oil and gas industry, the operator is concerned about minimizing your cost per well. And if you talk about steel is very costly. So if you have opportunity to shorten the length of your pipe, of your casing, it is always, you take that chance to do it. However, the determinant is determines that. Now, it is easy for you to bring that pipe to surface, because if you bring it to surface, you are able to have what you call a true bore straight to surface, and that true bore gives you a good strength. The smaller have more strength inside the pipe, because the last pipe typically is less. The last pipe is typically less stronger than the next pipe.
I've not told him. Okay.
In terms of capacity, in terms of burst, in terms of collapse. But because we know we can manage it again, case by case, you can manage it. But if you know that if you're going to run that pipe, that's why you have to run it to the liner. So the liner, the reason why we run liner is if we know that if we run it to surface, it will cause problem downhole. What are the problems I'm talking about? Problem like sludge. What is sludge? Sludge means as you are running it. Frank, mute yourself, Pico. Frankie. Frank.
Good morning, madam.
Put yourself. Sorry, I'll come back to you. Let me see if I can meet Frank. Okay, all right, good. All right, so the one key determinant why you want to run a liner, one key determinant is you are concerned about your downhole condition. Because if you run a full pipe, production getting to surface, information which is weak. In that weak zone, it is losses. And when you have losses, what do you have to do? You have to cure it. You have to pump cement, you have to pump some exotic chemicals to try and stop those losses. At the end of the day, you might spend days trying to cure the losses. You want to avoid that. So that is why you said, and you must have done the analysis, and that's where the engineering comes in. You do your tuck and drag, you do your surge and swab. You do all those calculations to tell you, if I run this string, because every weight of pipe you put in the hole, it's a weight overloading on the formation. Anytime you run a pipe, you're putting load inside the well. And there are some zones that are very weak. All the zones are not that competent. So that is why you run a liner and you secure it. A liner is shorter. Instead of running 15,000 feet of production casing, you're running only 1,000 feet. Can you see the difference? You have saved almost 13,000 feet, and pipe itself is very costly. Pipe is costly. 1 foot of pipe can cost you maybe $50, $70 or $100. So you are saving money, number one, and then you are securing your well. That is why you want to do liner. So cost is one driver, Number two, the formation downhole where the pipe is being run, the environment is another driver that makes you to decide to say, I want to run a liner. Otherwise, if every other thing looks good, you run your foot pipe to surface. The advantage of running a foot pipe to surface is that it gives you a secure well bore. The weight of that pipe, the strength of the pipe is able to withstand any pressure that is coming from within the well bore. But again, we have other ways of managing that. We do what they call tie back. You tie back after you have secured the liner. You run that same side of casing to go hook up with the last liner and bring it to surface. So so those are some considerations that we do take into hand. And sometimes again, with your liner, you are good enough to do your production, because if the well is not that high pressure, why do you want to run a full string to surface? You just run your liner, go in with your packer, set your packer, sting in, do your perforation, and flow the well. So case by case, that is done. If the well is deep, mostly if the well is deep, you see a lot of liners when wells are very deep. If the well is shallow, the cost difference and the advantage is not significant. You just run the full string.
Okay. Good morning, sir. I have a question, sir.
Go ahead, sir. Go ahead.
Okay. After well completion, the Christmas tree has been installed. Then maybe while I want to go in for an intervention job, the casing head hanger and tubing head hanger, which one is above each other?
Tubing is always at the top, because that's the last thing you run. You run your tubing, and you
the tubing is always at the top.
Yes, because after you drill the well, you run your casing hanger. Finally, if your well is good, you run your tubing hanger. Depending on the size of your tubing, 3.5, 4.5, or 5 inch or 5.5. Yeah, you land it on the wellhead. Yeah, and then you put your back pressure valve, you put down your BOP, and you pull up your Christmas tree, and then you flow the well.
Okay.
Hello, good day, sir. Hello, good day, sir. I have a question, sir.
Yeah, Zoom user, you don't change your name.
I changed it, it does not appear, sir. Okay, sir. Okay. You spoke about what we call intermediate cases, sir. Intermediate cases.
Intermediate casing. Yes.
Yes. Okay, fine. I ask a question. This intermediate casing, is it where your shoe track is, your float collar, your float shoe? Those are the 5 casing? Are those 5 casing that your float shoe and your float collar is? Is that what's called intermediate casing, sir?
No. So every casing you run, because you have to cement it, you need to have a shoe track. A shoe track consists of your float,
yes.
Your float collar and your landing collar.
Yes,
every casing, whether intermediate,
sure.
production, surface casing, everyone has to be run with a float shoe, which consists of float collar and landing collar. This is for you to be able to pump your cement. It has a check valve, one-way check valve, so you can only pump through and the fluid cannot come back. So intermediate casing is a casing. It's a casing on its own. Why we call it intermediate is because it is in between your surface casing and your production casing. We call it intermediate, that's in the middle, because we don't want to start saying surface casing 1, surface casing 2, surface casing 3, surface casing 4. We just said surface casing, intermediate casing 1, intermediate casing, yeah. It's just a nomenclature. But every casing, if you have to cement it, it must come with a float shoe, landing collar, float collar, and float shoe.
All right, sir. Thank you very much, sir.
Hello, sir.
Yes, go ahead.
Good morning, sir.
Good morning.
Okay, sir, I have 2 questions. One borders on the conductor pipe, and the other one is on the casing, the float collar and the float shoes. The float shoe and the float collar, what are the main purpose? And why do they put that thread compound, that Baker lock when they are putting, when they, before they usually run it, why do they normally put the thread lock?
Yeah, Baker lock. Yeah, so they
Yes,
call it Baker lock
they call
sometimes.
it Baker lock.
Yes.
That's one. Then number two, the conductor pipe. The conductor pipe, we all know that the conductor pipe, the depth with which it gets to is usually shallower than all other pipe, whether casing or the tubing that will be running. And everything is hinged on that conductor pipe. The question I now want to ask is, how does that conductor pipe able to withstand the pressure in holding the entire string? Since the depth with which they normally send it to is shorter. Those are my questions, sir. Thank you.
Thank you. Good question. Very, very good question. That is, who was that?
Precious.
Okay, Precious. Yeah, let's start with the latter question, the conductor pipe. The conductor pipe is from experience. I want to talk about land again. If you are going on a wide cut, yeah, they will have to do a lot of trial run to ensure that your conductor pipe is set to a point of no refusal. A point of no refusal, meaning sometimes you have to drill, and you get to a point where you say you have a very competent formation where when you run that pipe and you cement it, nothing moves it. And again, the cementing design for it is a little bit different from your normal cementing of your casing or your production casing. Offshore, we call it, we drive it with hammer, different types of design. You hammer it, boom. Probably if you've gone to offshore, you've seen, sometimes they do it on land too. They hit it, boom, boom, until you get to a point where the next blow doesn't make any difference in terms of moving the pipe downward. So it is always ensured that it sits on a very competent, solid ground, even though it is shallow. And if the area is shallow, well, you got to do something different. You got to move. Sometimes there have been issues where the conductor pipe was set and everybody thought it was good. And then when they put the well head, the well started subsiding. You have what they call subsidence. The well started collapsing. You see, it started tilting. We've seen it offshore and sometimes on land. So by experience. And rightly, as you said, it is very, very important because that is what takes the load of the well. It takes the load. And even after you've done all your analysis, engineering, or the stress check, there are occasions we have specialists have to go check to make sure that this subsidence is not happening. Again, overall, it's from experience to choose the depth. With experience, you know where you have competent, solid ground where that pipe can last and that pipe can be pushed to. You don't push it beyond because at the end of the day, there's no economics. There's a particular point you said, I think I'm good enough. It can withstand it. And you have to know your geological environment, the ecosystem, the place you are. Is it prone to earthquake? Is it prone to movement? All those things takes into play before you want to put a well there. So absolutely right. You're right. That conductor pipe is so crucial. And sometimes the operators have forgotten to put that in their mind when designing the well. I hope I take care of that latter question. Then to the former question, why is it Baker lock? Now, remember, after you run your casing, you have your float collar, your float shoe, everything is set up. You need to Baker lock because the next time you're going in there, what are you going with? You're going with a bit to drill. And the bit is rotating. If you look at the design of your float shoe, it's a very tight clearance. You have a check valve there. You have rubber there. So as you are drilling with your bit, the bit is rotating and it's kind of grabbing the side of that clearance because your next pipe, the next bit you're running, the ID has to fit in there. It's a very tight clearance. So if you don't Baker lock it as you are drilling, you might just break it apart. You might just separate it. And when you separate it, you've created a pathway for encroachment. Because at the end, at one point, you may want to do a leak-off test. again, I didn't mention it again. I did mention a few things here because of again the scope of the content here. You do a test, and if you don't do it well, when you go to pressure test your casing, you start seeing leakage. You say, what is happening? Where is my leak from? After all, the casing was made up properly, run downhole well. But because that shoe track has been disintegrated, because when you go in with your bit to start to drill, it is grinding, it is rotating. That's why you see some junk coming out of the hole. When you are drilling your shoe track, you see junk coming out. We want that junk to be junk inside because it is typically filled up with cement. We don't want that to disintegrate before the bit goes and drill it. We want you to drill it smoothly so we can drill the next hole section. That is why most times we bake a lock it to make sure it is tight fit. We don't want you to back off, because there's thread, there are thread, and because the bit at that moment when it gets there is stationary for some time. It is rotating. It takes you a few hours. It's not like you are running inside the pipe with the bit, then you are drilling. No, that point there, you are drilling something hard because there's cement part of the shoe track. Inside the shoe track, there is cement. And for you to do that, you need a solid, compact sub or end of the pipe to make sure that nothing gets loose. Am I good?
Sir, yes. Sir, you just answer one part of it. I said, what's the purpose of that float collar and the float shoe? Because if you look at the design of the float collar and the float shoe, you see that it's usually oval. Why is it? What is the purpose, the function of those components? I just want to know.
The component.
Thank you, sir.
Good question. Good question. The purpose again is a check valve. One of them kind of opposite direction. Is to make sure that when you pump your cement, you know, by your pumping cement, you have fluid at your backside. You don't have YouTube. Hello?
Hello, sir. Go ahead. I can hear you, sir.
Yeah, you don't want to have YouTube. That's why typically you have one joint, again, depending on the design. You can have one joint for separating your float collar from your landing collar. Okay, your float shoe, one joint. That joint is filled with cement. Typically, we don't want to pump and over displace that portion. We want cement to be there. We want cement to be, that is why we have the float collar and the float shoe and the landing collar, to have some security that at the end, when your cement job is done, we don't want to see a backflow. We want something integrity before we go back, because it takes a long while. After you run your casing and you cement, if you don't have that secure barrier at the shoe, for any reason, there is high pressure below you, it will want to come to the surface inside the pipe and to all the way to the rig. So that is why you have that length. Typically, it is 80 feet. Some people sometimes want to increase it to 120. Again, some people want to put one joint, depending on the region and the pressure on the next zone you want to drill. That is why you have float collar and landing collar, to secure that last 100 plus minus feet of your casing in case of pressure, unforeseen pressure below the last point you've just drilled.
Thank you, sir.
Copy? All right.
Yes, sir.
All right, gentlemen.
Hello,
I think everybody's back, right?
Hello, sir.
Yes, yes.
Sir, please, just in a nutshell, just explain small about the tie back. You are talking about completion, tubing, and you talk about the tie back. Just the tie back. I didn't actually get it clear.
Mr. Who is this one? What's your name?
My name is Kenneth Obunna.
Kenneth, I always see your number, Mr. Kenneth. Mr. Kenneth he wants to take me to the moon. All right, tie back. Yes, tie back. Typically, we're talking about liner and full string casing. So in deep wells, mostly in deep wells, we want to manage our target reservoir. Typically, your liners are run across your target reservoir again, because it's very sensitive. You don't want to surge it. We talk about surge and swap. I hope probably you guys know the difference between them. And surge is when you run something in a hole and you are putting pressure down hole. Swap is when you are pulling something out and you are trying to make the hole light. One of the cases, if you surge, you may have losses. If you swab, you may have well control. The well might want to come on you. The well might want to flow. So in the latter case where you have surge, where you're putting pressure on the reservoir, it's possible that during that scenario, if you run a full string, the hydrostatic pressure, remember the hydrostatic pressure equals rho GH. The lengthier, the longer the length of your fluid in the well, and the heavier it is, the more the pressure will be. So if that happens, you will have losses. And you go and start combating losses and resulting to one issue or the other. So what we do typically is we run the liner. We run the liner and secure that your production zone. And you hang the liner on the last 300-500 feet, again, depending on the operator's discretion. You hang that liner there and you cement. Everything is secured. Now, the next thing you want to do is, some operator says, okay, because my previous casing before running the liner doesn't have good strength in terms of burst. In terms of burst, it could easily burst when my well flows and there's a leak. It's a leak part. They want to tie it back. So what they do is the last liner they tie, let's say for example, it's a 758-inch liner. They just run it and secure it. They want to go back and run the remaining half of it to bring it to surface. So they run in with steel assembly or PBR, we call polypore receptacle. They run it and go sting in to the last liner. They sting it in. So you now have and cement it also. But where are you cementing? You are cementing behind a pipe, not behind a formation.
Okay.
You are cementing that type. You are cementing the tie back behind the casing. So there is no surge. There is no potential for you to break that information. So it is another way to secure it. And the purpose of that is you want to, the casing has enough strength for production purpose. And this is something the engineers would have done to say, you know what, I need to do the tie back because if I produce this well, if there's a leak, the last casing that the pressure we see might burst it. But if I put the tie back, it will secure it. My well will be secured. Again, it's not all the time you do that. If your well is not highly pressurized, you don't need to do that. You just go ahead and run your tubing, and sting it in with steel assembly, or run the packer, sting in, and then you proceed. Is that good enough?
Thank you very much. Yes, sir.
All right. Okay, gentlemen, let's move on. I've taken most of the time. I'm trying to move fast now. Okay, I think we wrapped up here. How a well is drilled on land. Yeah, we've said so many things. Hopefully you got some notes. You picked up one of two nice points here just to give you a glimpse of what drilling is all about. Again, this is not, again, we're talking about introduction here. There's so many things we could talk about, but because of the limit of global skills content, I'm trying to make sure I don't go beyond the requirements here. But of course, you guys know how to get back to global scale and tell them I need more. All right, so let's talk about directional drilling. Before we go to that, I just want to give you some few notes here. I hope my screen, I can share my screen here. Let's see. Where is that? Let's go here. Okay. Can you see my screen?
Yes, please.
Okay, directional drilling, few notes. All right, this is going to be short and sweet. Now, what is the objective of directional drilling? Again, it's introduction. The objective here is to I want to describe to you.
Hello, sir. I'm not seeing your screen. I'm just seeing your folder.
Okay. This stuff started. All right, let me pull this back. Close this. Close this. Okay. Screen sharing has stopped. Shared window is closed. Okay. Where is that? How about now? Any change?
It's just showing the zoom, just only the zoom.
Yes, sir. Yes, it has come up. Intro to directional drilling.
Yes.
Yeah, the slide is on now. The slide is on now.
Okay, thanks, son. All right. So a few notes now. just to give you objective of this slide, we're going to describe and discuss the principles and.
I can't see the slide though. Sorry, I can't see the slide here.
Okay.
Please proceed. We can see the slide is obvious.
Frank, do something.
Slide is visible.
Frank, do something.
The slide is open now.
Okay.
Is it not objective to describe and discuss the principle and mechanism? I can see it now.
Okay, good. Yes, that is like. Okay, so we're going to describe the mechanism and principle associated with directional and differential control in the process of drilling the well. Just the principles, nothing big, let's say. Yes, I have to add this slide for you guys. Something I added. It's important for me to describe this to you because one of the big challenges in drilling directional well, just like we mentioned previously, is that the industry, what is changing. Countries are becoming to see the need for oil, even though we have Greenpeace who says stop drilling, no more drilling, and we have what do you call it? Everybody's trying to go to renewals, but nevertheless, it is still clear that we need oil and gas for the next couple of years to come. We don't know when that end date is, but oil and gas is still important. Just like you can see what is happening in the Middle East and in Asia, even Africa, you see everything goes to oil price. So the challenges are increasing. In the past, countries drill vertical wells, easy. The cheapest well you can drill is a vertical well, I would say. Although sometimes that statement is not a blanket statement, but cheap wells are vertical. Just go straight, drill, boom, you produce. But because the reservoir, again, we get back to reservoir, remember, pressure, rho, GH, the reservoir pressure are depleting. The pressures are reducing. So the only way you can tap more hydrocarbon is to go deeper and deeper. And other things associated with that causes one not to go that far, not to go that deep. Some restrictions. So what are the drivers? What are the drivers for directional drilling? What is making us to go to directional drilling? Strong economics. Strong economic because you cannot get cheap oil shallower anymore. And where the oil are located, the hydrocarbons are located, are way off territory where you can move a rig easily. And then environmental pressure, of course, as I said, environmental pressures, either from Greenpeace or from government, like places like California, for you to drill a well there, it will take you so much paperwork that you abandon drilling the well. Alaska, again, they say it's a pristine zone. Go to somewhere like Maldives, there's no oil, everything is imported. You cannot drill because of the coral reefs and all the beautiful nature you have there. So a lot of things are driving directional drilling. But nevertheless, we still have to drill directionally in order to sustain and meet up the global demand for oil and gas and for all the products that comes associated with it. So I showed you this slide here. As you can see, this slide figure 8.8, I'm sharing with you because if you look at it, it gives you a general perspective. What are the challenges you face when you're drilling? Why we do a directional well? You can see to the right, you can see a boat. You can see a boat like a river there. The boat is kind of whoever is cruising there. You can see houses next to it. I'm talking from my right to my left. You see the river, you see houses, and then look at where the rig is located, in a kind of behind, somewhere plain. Now, the question is, it would have been easy for the rig to go to the center. You can see a spot there where they call horizontal departure. The rig would have just been moved to that spot and drill a vertical well, easy. But of course, you can't do that because regulation. It says, no, you cannot move that rig to that water. Either it's a jackup or deep water. You cannot move it there because that water is for recreation, swimming pool. I mean, not swimming pool. What do you call it? Beaches. Very exotic animals on the sea. You can't put it there, otherwise you pollute it. So they have to stay far away. So all these are restrictions. And so because of that, there are different types of, the directional companies have to work with the operator to say, okay, where is my target? Where is the oil? Where do I think the oil is? What is the best way for me to reach there with all the restrictions? That's where you have different shapes of directional profile. As you can see from the diagram, you can see, I can list for you probably 4 types. You have what? The build and hold. The build and hold, that is A. You go to B. B is called the build and hold drop or hold or modify S. And you can see the other one there, build and hold drop S type. And you can see the other one, continuous build. So these are all the different types of profile. We call it trajectory. So take note of it, trajectory, different types of trajectory to drill a directional well. It can be a modifier of any of these 4 I've mentioned here. But you can see how complex it is. Each one has its own constraint. Each one has its own economics and downside and pros and cons, of course. But at the end of the day, what is the objective of the operator? I want to drill this well safe as possible. Safe as possible and low cost, very low cost. So if a directional company like Schlumberger, Baker, Halliburton, Weatherford comes to me, and I said, okay, this is my target. Give me a profile. They gave me 1, 2, 3. I said, no, I don't like this. Give me another one. At the end of the day, I will calculate how much footage I'm going to drill, because for each leg you are drilling, there is a cost associated with it. So at the end of the day, I have to find a balance. I want to meet my target, and I want to get the safest. I want to get the cheapest. Again, sometimes the cheapest is not the best, of course, but all this has to be in the books. It has to be on the table to discuss. All right, a few things to mention. What are the steps to planning a trajectory include? First and foremost, the geologists. The geologists, these are the key individuals here that gives us the direction. As a drilling engineer, my closest ally is the geologist. He gives me a target. It gives me a target depth. It gives me a target radius, and it gives me a horizontal departure. How far he wants this well to be drilled. What depth? How many targets? Sometimes you could have more than one target, gentlemen. Not necessarily one target. I can try to economize. I would say economize is the wrong word, probably. I can optimize. Economize is not a good word in the oil and gas industry. You optimize. I want to optimize my profile so I can hit several targets. So I have options to produce from one zone. If that zone dies off, I produce from another zone. Secondly, I need to set a kickoff point so that I can have those profiles we talked about. Remember, we could have different profiles. What are the profiles again? Build and hold type, continuous build and hold and drop, and build, hold, and drop. So I have to make a decision. Which one should I go with? And then I have to calculate my maximum inclination. Maximum inclination is, what is the maximum? Is it a 90-degree horizontal? If I say 90 degree, it means horizontal well. If I say 85, is it highly deviated? Or if I say a kind of deviated 50 degrees, 60 degrees, or is it close to vertical 30 degrees, 15 degrees? And then fourthly, I need to determine the lead angle. What is the angle I'm going to start up with? What angle? And estimate the rate of direction change. So as you are drilling directional well, you are building angle, and there's a word we call dog leg severity, DLS. Write it down, please. DLS, dog leg severity. It means how much build do I want to? Oh, yeah, I think I need to also mention this. I didn't talk about it, how to drill a well. Now, depending on the rig, you have to drill a well. It could range from 1,000 horsepower to 3,000 horsepower. There are different types of rig, and the power of the rig determines how deep you want to drill. Typically, the higher the horsepower, the more capability it gives you to be able to drill deeper. You go deeper, the greater the horsepower. Now, for some rigs, they can drill in singles. Single, they pick up their drill pipe. This is the pipe that allows you to drill as you go down the hole, you keep making the next joint. They could pick singles. The height of the mast, we'll talk about rig equipment very soon. The height of the mast is limited. You cannot pick more than one at a time. You can pick two, they call it doubles, and you can pick three, they call it triples. So there are bigger rigs that can pick quadruple, four pipe at a time, make it up and you run. The more you can pick at one time and make it up and put on the derrick, it allows you to drill faster, it saves time. So now typically general practice is triples, which is mostly 3,000 horsepower rigs. For each stand, we call it a stand. A triple is called a stand. Remember that, please. When you have three drill pipe made up together as one long string, it's called a stand. So three pipe typically in a range of 30, 33, 31 feet in length. If you make it up, typically we say 100 feet. So that 100 feet is a stand. So most deep rigs, 3,000 horsepower, 3,000 horsepower. So you could have single, double, triple, or quadruple. If you have three pipe made up together, it's called a stand. In directional drilling, it is very common to use the triple as a standard, which is about 100 feet. So for every 100 feet you drill, you want to have built a certain degree to take you to your final inclination. So that is what we call dogleg severity. So it could range from 1.5 to some, again, depending what you're using, up to 10 degrees per dogleg. With the higher the dogleg, the more severe your trajectory looks like in terms of tortuosity. And typically you have to be careful with the kind of BHA, bottom hole assembly you use to achieve that. Okay, all right, set communities here. All right, okay, just so briefly. And then how do we achieve this trajectory you are seeing now? Can you see my slide?
Yes.
Okay, now we say we have typically 4 types of trajectory and something in between. How do we achieve these trajectories? There are different equipment or tools that can help you to build, to kick off. And I just want to mention them here. We have a simple whipstock. Whipstock is the kind of a mechanical assembly that just gives you opportunity to be able to bend your direction, to change your direction you want to go with your BHA. The other technologies have come up in recent years. We have mud motor, a mud motor equipped with bent sub or bent housing. This is mud motor. It's like a motor. You have rotor and stator. It rotates. So as it rotates, there is a bend that is added to it to deflect it, to make it deflect. If you want it to go east or west or north or south, there's a command they give to it, and it bends. And as it bends, it goes to that direction, and you can change it either in sliding mode or in rotation mode. It changes accordingly. And then we have what they call jetting bits. There are certain bits you put in your BHA, which jets, which kind of discharges some certain amount of force to cause your tool to bend to a given direction. And in recent years, now it's no more new story. We have what we call rotary steerable assembly. These are tools, specialized tools provided by service company that allows your BHA to be able to take signal from surface, and you tell them where you want to go. They just follow you. They just follow. We have different type, push the beat, point the beat. These are different technologies by different provider, either Schlumberger, Baker, or Weatherford. So these are the different technologies so far available for you to be able to achieve your directional control. Sometimes we use cement. You set a cement plug, and then from the cement plug, you kick off. The cement plug is hardened. As your bit gets to rest on the cement plug, your bit tends to deflect. As it deflects, it goes to the direction you want it. We have tools that enable you to tell you where you are going. We have what you call MWD, measurement while drilling. It tells you your inclination, it tells you your azimuth. This is just the schematics I added here to show you the top three I mentioned. The first one, you can see the whipstock. It's like a deflected tool, metal, and it's as the bit comes in, it has to follow that deflection direction, and it goes that way to the left. A mud motor with a bend sub. There's a motor here. The motor rotates. As it rotates, there's a bend. See that bend makes it to deflect to the direction you want. And then we have a jetting bit. As the fluid is coming out of the bit has nozzles. So depending on the force, it can force the formation to wash out in a particular direction, and after which you continue drilling towards that direction. Okay, all right, now let's go to the slide proper. Can you see the slide? Can we see this slide?
We are seeing the lower part of it, but the upper part of it, we can see from down water, oil, and gas. That's all we see from down.
Okay. This is it. Okay.
Okay,
now,
it's complete now.
This is an animated slide provided to me by Globat Scale. I hope you guys will enjoy it. But if there's any question on it, I'll definitely take your question. So just follow me as I click. Something will be appearing on the screen. So it's very interesting. All right. So now, what you're seeing right now on the screen is, as we talked about previously, we have gas, we have oil, we have water. One of the challenges, again, when you are, or an operator wants to produce, their concern is mostly oil. Again, oil price now is about 80 plus, gas price about $3.something. So everybody wants to produce oil as quick as possible. But where you have the oil, the location is becoming very trickier. That you may have to go and do a lot of maneuvering to get to where the oil is. One, it could be either very deep, and secondly, the layer of the oil could be very thin, that putting a vertical well is not economical. You want coverage. In fact, statistics and data shows that one directional oil well can replace up to 20, 30 vertical wells. So why would you not want to drill a directional well? Well, the only reason I can think of is if you don't have the technology. But the technology is there. The technology is there for you to drill a directional well. So most operators right now, they are going for directional wells. Well, before you drill a directional well, first of all, you must know where your reservoir is. And that is why you have to drill a vertical well. So somebody will ask you, why do we need vertical wells? Well, vertical well is for appraisal purpose. It's for white cat. So when you are given a location, you're given a new field, and you don't know anything about it. You don't know where the oil is, how thick the oil layer is. So you can't just start drilling a directional well. Although we have service company that has special tools they call it geosteering. Geosteering means they have sensors in their tools that can tell you, oops, there's oil here, let me go here, there's water here, or stay away from water, there's gas here, oh, move to the left, move to the right. But that is like a wild goose chase, and it will cost you a lot and time. So easily go ahead, drill a vertical well, identify your target, identify your depth, identify your thickness of your reservoir, and then you come back and do some more seismic activities, and it will help you to analyze, understand how vast your reservoir is, and then you can decide what kind of well to place. Sometimes, again, as I said, it's not a blanket statement. Some vertical wells sometimes are needed, and depending on where you are, you just can't do a horizontal well because the length of the oil zone or your target zone is not that much. So it would be kind of useless, not useless, but the expense, cost benefit is not there. So you have to just drill a vertical well. But overall, industry has proven in recent years that horizontal well is the key to go. That's where you get the best out of your money and cost per foot. Okay, so the diagram top there, it shows you the bid. It shows the mud tank, of course, and I've not mentioned much about mud here. I think probably in the drilling equipment, I'll talk about that. Mud tank, so we have mud. Remember, we talk about mud, hydrostatic pressure. Let's just remind ourselves. I don't know if there's anybody joining us the first time, but if you have not spoken before, could you just enlighten me here that what are the 3 types of possible ways you can drill a well? What are the three ways out there people are drilling wells? Depending on the pressure. Depending on the pressure. I mentioned 3. What are they?
1, manage drilling.
Manage pressure drilling.
Yes. For manage pressure drilling, unbalanced drilling, and conventional drilling.
Okay. All right. Thank you very much. Somebody else should explain to me what is meant by conventional drilling. Somebody else. Conventional drilling, quickly.
Hello.
Yes. Yes.
Yeah, conventional drilling. This is when the weight of the mud is more than your formation pressure.
Thank you very much. Yes, your hydrostatic pressure on the reservoir is greater than the reservoir or the formation pressure. Somebody wants to tell me what is underbalance drilling?
Hello. Yeah, underbalance drilling is kind of drilling where we have the hydrostatic pressure being less than the formation pressure.
Thank you very much, Udom. That's right. Hydrostatic pressure less than the formation pressure. Yeah, so that way you are taking the fluid in. You are taking it consciously. And again, all these 3 methods I mentioned is a conscious effort. It's something we go in knowingly. We don't go and find ourselves doing otherwise. Say, I want to drill conventionally, and then suddenly I find myself doing underbalance drilling. No, because the system has to be set up. It requires specialized equipment, especially for underbalance and managed pressure drilling. You have to set up your rig to accommodate that. Otherwise, you get into trouble and you have a well control situation which no one is prepared for. Okay, all right, so we have the mud. Now, the mud, in this scenario we have here, I would say this is conventional. So we drill, again, we talk about where do we stop? Okay, let's just remind ourselves again. All this we talked about quickly, so we should be fast. What are the considerations? What are the considerations you always take with you when you are drilling, where you have to set your next casing? What would you consider to be the end point to say, okay, I need to set casing here and pick up my next drilling BHA?
Formation pressure, sir.
That's one.
And the formation
type.
And the type of formation.
Yes, and the type of formation you want to isolate. Maybe you have cold bed, you have low circulation zones, you have salt, you have reactive shell. You want to isolate it. Okay. All right. So first thing now, there's a big word here. Spud. What is spud? In a conventional drilling operation, when we say spud means when you have made up your BHA. By the way, I know I use that term loosely. I hope I've not been saying terms which you don't understand. Please, if there's any terminology or abbreviation I'm mentioning, you don't know what it is, please call my attention. So for that sake, somebody tell me what is the meaning of BHA? BHA.
Bottom hole assembly.
Okay, all right, you guys are the best. Yeah. Okay, so good students. All right, so when your BHA with your bit touches the formation after your conductor pipe. Hello, somebody's making noise. Please mute your Friday, mute yourself, please. Friday, mute yourself. Thank you. Friday, mute yourself. Udom, mute yourself. Thank you. All right, now, what is spud? the question is, what is spot? Spot is when your bit on the BHA touches the formation after your conductor pipe is set. The first contact with your bit on the formation after your conductor pipe is set is called spot in. This is a general universal term we use. Again, I can't recall anywhere else where I've worked. I've seen it defined differently. For drilling again, it's not a walkover, it's not doing completion. So spot means you pick up the conductor pipe is the conductor pipe is already set. Now you're ready to drill. You pick up your BHA, you make up your BHA drill collars, everything is ready. You put your bit, and now you run in hole and you tag the ground. You tag the ground just after the conductor pipe, and the bit just rotates to make any contact and create any cuttings. That is when we say the well has spotted. It is very important because for most cases, the contract between the operator and the rig contractor, that is when they start getting paid. That is when they start counting their hours. Contractors are paid according to the hours the rig works. So if he works 12 hours a day, that's what he gets. So when the well finishes, the last day, whether it is midnight or 1 p.m. or 3 p.m. or 6:30 a.m., that is when it ends. So you need to know that timing, and it is recorded in the daily drilling report. Okay, let's see what happens. So we're spotting. Now it says kick off with a bent joint and motor. Remember we talked about it already that a motor is one way we can achieve directional control. Yes. Now the diagram you're looking at, it just again it's just a typify, just telling you what's going on. But just recall that the kickoff depth is determined by the geologist. Where does he want you to kick off? So you don't kick off immediately from the shoe or from your conductor pipe, not necessary. You may have to kick off somewhere in your intermediate, after your first intermediate casing, or after your second intermediate casing, or after your third intermediate casing. There's a particular zone where it is suitable to kick off. And typically, you kick off in a zone where your formation is not too hard, so that it easily can kick off. You don't kick off in a very hard formation where the strength of the rock does not allow your tool to bend. Okay, so in this picture you are looking at, please don't get confused. We're not kicking off from the shoe. There's somewhere deep downhole we are kicking off, but it's just telling you that one way to kick off is using a bent sub or housing with a motor, all right, with your BHA. The mud tank is shown there, of course. Remember, mud, we'll talk about mud. We'll talk about that hopefully later. Mud itself allows you to do so many things. One, helps you to cool your drain string. The BHA allows you to cool it down because the more your pipe is rotating, it's getting hot, it's hot. It cools it down. That's one major use of the mud. Number two, the mud also allows you to take the cuttings because as you're drilling, you're generating earth, call it cuttings. Those cuttings have to be taken out of the well for you to drill ahead. Otherwise, it will be congested in the hole and it will cause the well to kind of the BHO to get potentially stuck, could get stuck if you don't remove the cuttings on time and timely. So that's just giving you a picture of what is actually happening. So we kick off with a bent sub with a motor. So that's one way we can do that, of course, with your beats. Next, he said you build up and go to the next casing seat. Now, depending on the profile, remember we talk about you could have different kind of profiles. Let's just remind ourselves again, for those who are joining us and those who are following, can somebody give me one type of profile, but potential profile for directional well, a trajectory, one type? Yes, build and hold. Thank you. Next, somebody else, another one.
Hold, build, drop.
Thank you. Another one.
Continuous build.
Thank you. And finally. Okay, we're exhausted. Yeah. Okay. modifiers. You can have a build and hold. Again, build and hold depend on the type. You can have the modify S. You can have the trajectory and S of course, S curve modify, S shape, and the rest. So that's good. All right, so let's move on. So you continue building again with your lead angle to take you to the next kickoff point. Again, depending on the shape or the trajectory you have chosen, this process continues. It does not change. It doesn't change what we said, how to drill a well. You drill according to the next casing seat. With casing seat, what I mean by casing seat? Casing seat is the next point where you need to set your casing because of the factors we mentioned. The formation you want to isolate and the pressure regime you are about to enter into. You do the same thing. You cement the casing. After that, you pull out of hole. When you come out of hole, you go with the next BHA. One of the things, of course, you notice is that the more as you keep going downward, your string is becoming smaller. You cannot start with small and go to big. You drill big hole, the size reduces, keep reducing, keep reducing, keep reducing. And that is why most times in designing a well, you design bottoms up. When designing a well, you design bottoms up. What I mean by that is you want to know how much you can produce. What is the hole size, the biggest hole size your fluid will have to flow? We call it the inflow production test. You must have done analysis. If it's a development well, you know what it can flow. If it's a wildcat, well, you don't know, you have to do a lot of trials, but there are software available for the engineer to, reservoir engineer to run his analysis and say, this well can produce 5,000 barrels per day. Okay, 5,000 barrels per day, what does that mean? It means, do I need a 3.5 production tubing or 4.5 production tubing or 7-inch production casing? You know, so what do I need? So that determines, and with that, you know what to do. Of course, before then, the geologist will tell you. Remember, I talked about a few things here that you need to know for planning a kickoff. I think I mentioned that earlier. We said we need to plan a directional well. We need some few things. Yes, we talk about what. Can you remind me, somebody, what are those things that is needed before we start doing a directional well? The steps. Remind me, mention some steps we need before we start to plan a directional well.
You need a geologist.
Okay, yes, very important. A good friend of yours. What does it give you?
It gives you the tangent depth and areas of target.
Yes, it gives you target depth and number of targets, and also tell you the radius. Okay, and what else it tells you? What does the geologist tells you? Where to do what?
Kick off.
Yes, where you have to kick off. So yes, kick off point, which is part of the directional drilling. That's why as we keep drilling, we keep setting our casing. Our aim is we are trying to go to where we have to kick off. And to kick off, somebody remind me, what are the options we have? What are the 4 options we have to use? What tools do we have we can use to kick off?
Whipstock.
1.
Mud motor equipped with bench sub.
2.
You can use mud motor.
Yes, 2.
Jetting bit.
RRS.
3. And rotary steerable assembly. Correct. Okay, guys. I think you're already a directional driller now. Okay. All right. So you pull out of hole, you run your casing. Again, whatever casing you're running, either intermediate or production casing, you cement, you place your BOP. Remember, we talk about that. Your casing head, the same process. You put your casing head, you put your casing hanger, you put your BOP, you drill, continue, you drill, and then this one drill out with hold assembly. Now, sometimes you have to hold. Remember, we have. It's the build and hold, right? You build, it gets to a point where you may have to hold. Again, this is all determined or agreed upon between you and the geologist before you start drilling. Okay, and then pull out of hole, and you run your casing, and then what else here? Run your casing, you pump and display cement again, you run the casing cement, you drill out with a drop now. This one is a build. I think what the example we have here is a build, hold, and drop. So you drop and then drill to TD, and that is it. You're done with your.
Excuse me, sir.
Yes.
Please, the slide is not magnified. Can you help us magnify it?
How is it now?
It's not showing at the center. It is your picture that is showing at the center instead.
My picture? Me? Am I showing?
No.
Yes,
it's supposed to be your.
It's showing. Just zoom on your own screen. If you're using your phone, zoom on your own screen.
Okay. How is it now? I've just tried to expand it. I don't know if you make any change, any difference.
You can zoom it on your side. Just zoom it. It will zoom.
Okay. All right. I didn't mention. Just again, this is again from Global Skills. I was given some materials to share with you, so I am limited to what I can share. Again, it's introduction, guys. It's introduction. So I know you want so much, but your questions will be welcome to compensate for the limited. When I say limited, I would say just enough information for you to get that general overview of directional drilling. Directional drilling, again, it's a little bit complex, not that easy, because sometimes one of the challenges in directional drilling is that you start to drill and suddenly you get to a point where you are building. Remember, I talk about DLS. Somebody remind me, what is DLS?
Douglas severity.
Yes, the Douglas severity. You are drilling. You say, I want to drill with 5 degrees per 100, 5 degrees per 100. And suddenly, because of the formation change, downhole. What is downhole? It's almost anybody's guess. And sometimes the formation changes and becomes longer, and you don't anticipate it, and you get into problems. So sometimes you get stuck. Your pipe gets stuck. You were drilling with 5 degrees per 100, and then suddenly you get stuck. You are able to fish. When I say fish, you're able to retrieve your BHA, and then you go back and you want to drill again. You are not able to achieve the 5 degrees. Now you want to go to 6 degrees. It becomes a bit complex. You may have to change your directional profile. And sometimes you go into fish, you cannot fish out the BHA. Lucky, please, can you pause your mic, please? Thank you. Yes, so you are drilling with 5 degrees per 100. Your BHA gets stuck, your bit gets stuck. You try to fish it. Fish means to pull it out. You cannot. You go set a bridge plug or cement, and you want to kick off. Now you want to kick off. You go with a different assembly to try and kick off. You cannot, and suddenly the place you have to kick off becomes shallow. If it's shallow, it means you need to make more to compensate for what you have lost. So, things could change. Things could just change. You wanted to go with a motor bend sub, maybe 2.5 degrees bend sub, and then suddenly now you might have to go with 3.1. And the more you put, the more aggressive you are on your BHA, the more potential that your tools might get damaged. Either you get, you have what you call, the string twisting, twist off. You have twist off, or you have back off. You are rotating, and the thing just back off from the way you make it up. So complications. There's so many complications, and sometimes you're drilling directional well, you get into a lost zone.
It's 3 hours, please.
When you get to the lost zone, what happens next is you need to stop drilling and suspend and put a cement plug. It delays you for some days, and all this adds up. It becomes a big problem. So typically, all this has to be considered. All right. Okay. I think that's all for directional drilling. Let's take some questions. We'll take a 5-minute break, then we wrap it up with drilling equipment. Let's take some questions. 3 questions. I'm ready. Go ahead.
Hello, good day, sir.
Yes, go ahead.
Please, at what angle
At what angle do you deviate during a directional drilling, please?
I don't think I get your question. At what angle you what?
At what angle do you deviate? If you want to go directional drilling, you're going straight. At what angle? Is it 30 degrees, 70 degrees, 50 degrees?
Well, directional drilling overall, when we say directional drilling, typically we say you are directional drilling when you are above 15 degrees, plus minus 15. When you start building and you are just about 15 degrees off from your vertical, you are already directional. You could start building angle from any point in time. If you are drilling a vertical well, again, depending on the kind of assembly you have in hole, you could have a pendulum assembly. Pendulum assembly is the kind of assembly that allows you actually to flex your tool, and depending on the formation, your tool will just always want to go to the high side. Means it wants to make you to build, not to stay straight. We have what they call stiff assembly. Stiff assembly, again, depending on how you design it with drill collars, stabilizers. It makes your well to be straight. So directional wells, typically, when we say well is directional, we say from 15 degrees. So directional, when I say directional, deviated, then horizontal. Horizontal, of course, 90 degrees. 90 degrees horizontal. If I say deviated, 50, 30. If I say highly deviated, 75, 80, then horizontal, 90 degrees. All right. Any question again?
Yeah. Between
okay, sir.
Between
me here.
Sorry, sir.
Ezra, go ahead.
Hello.
And the horizontal.
Ezra, let's allow Ezra, go ahead.
Between vertical drilling and horizontal drilling, which one is more longer to the formation?
I think somebody can answer that question. It depends on the geology, where his target is. A geologist tells me his target is at 20,000 feet. Okay.
Yeah.
What profile does he want me to get there? Of course, first and foremost, remember we talk about what are the things we need in order to plan your directional drilling trajectory. First, we need a geologist to give us a target depth. It tells me my target depth is 20,000 feet. Okay, 20,000 feet. Now, how many targets? What is the radius? And then he tells me that depth already he must have done his analysis and said 20,000 feet is because I want you to kick off at 8,000 feet. So it tells me that. So all this depends on the target, where the target is. Wherever the target is, I need to get there. So it gives me a target, and then from the profile, I see how much length it is. But typically, of course, a vertical well has a shorter length than a directional well. Of course, remember, measured depth, TVD, right? Directional well is measured depth. Measured depth. The length, the total length is measured, but the TVD is going to be fixed compared to, say, give me a vertical well. So I can drill a vertical well, the TVD is 5,000 feet. I can still drill a directional well, TVD is 5,000 feet, but the measured depth is 18,000 feet.
Okay.
Yeah.
Thank you, sir.
Excuse me, sir.
Yes, sir.
Okay, sir, I want you to throw more light on the difference between a deviated well and an horizontal well. And again, if between the deviated and a horizontal well, do you really need a directional driller when you are running a deviated well? Please, I want to throw more light. Thank you.
Yes, deviated well, when you say horizontal, it means you are 90 degrees. And all this depends on the call it, how do I say, the seismic analysis that have shown where the reservoir is. So depending on what the geologist is saying, they may want to request us to do a horizontal well. Remember, I did mention this again. It's not part of the. I'm not a geologist, but of course, I can talk about faulting. Talk about fault, different types of fault, strike through, and different type of fault. So if there's a fault, it makes it more complex because now instead of you have that continuity of your reservoir, you may have to cut it across two different strata. As a result of that, you drill and then you hold, you drop, and then you go to the next one, you drill the horizontal. So if you have that kind of scenario, potentially you may want to, it may become highly deviated. But if the strata of your reservoir is uniform across the field, what I mean by uniform is there's no much fault in the seismic shows a fine line that this reservoir is continuous. Continuous again, of course, continuous is not that straight, but a little bit undulating, but it's continuous. It's a very potential well for horizontal well to put at 90 degrees. So what you just need to do is just continue building. And when you get to the point where you want to penetrate the reservoir, you just go ahead and just continue with your dogleg severity required. And then after that, you just hold it 90 degrees and just keep it flat and drill to the end. Directional, you talk about the need for directional driller. Yeah, I think operators are not specialized directional driller. You need them, and that's their job. You need a directional driller if you're drilling a directional well. They know their tools. The operator doesn't know their tools more than the service company. And if you want to drill a directional well, yes, you need directional specialists like those who are good in motor. You could drill, if your question is, could you drill a directional well with a motor assembly or rotary steerable assembly? Yes, you could do with either, depending again on the expertise of the directional company. But definitely you need directional drillers. That's why directional drillers, that is what they do. Because the signals, they are sending signals, they are taking data from subsurface to surface and telling you where you are. The company man doesn't know, it's not an expert on that. That's not his field. He's to monitor, supervise the job, and make sure it's done. So you need them, and you need the MWD specialists also, those who are taking the measurement to make sure that you are the right inclination and azimuth.
Hello, sir.
Yeah.
Hello, sir.
Morning, sir.
Yeah, sir, you talk about hello. Hello.
Hello.
What at the time? If I go ahead first, we'll come back to the other guy.
Okay, sir. Okay, sir. You spoke about LOT, lick-off test, and talk and drive. Can you please explain about this LOT test and talk and drive?
Mr. Ifeanyi. Okay. All right. Let's talk about lick-off test first. Now, depending on where you're drilling, especially for cases where you have, again, there are different types of wells the geologist can ask you to drill. Most times you can have wildcat. Wildcat is a well where it's the first time they probably, say for example, I know in Nigeria now they say there's oil in the north, right? Kaduna, Kano, or whatever, where is it, or Maiduguri. Those places are places not typical where you see oil well. So first and foremost, the seismic has shown some signs of hydrocarbon, but there are very few wells, if any. Maybe one or two have been drilled many years ago. So those are white cats. And then you come to the south, right? You come down to the southeast, Port Harcourt, Warrior, that's part of the area, Kwaibom. There are a lot of wells that have been drilled there. We know what the terrain looks like in terms of the strength of the reservoir. So lick-off test, that's what they call lick-off test and formation integrity test. Now, we talk about that if you want to set your casing, there are two very important parameters, two things you need to know, maybe more, but two very important. One is you need to know your casing seat. Where do you want to set your casing? And it depends on what? The formation you want to isolate and your formation pressure beyond that point. You don't want to set your casing inside a very high pressure zone, which will not allow you to drill ahead. So typically you isolate your zones according to pressure regime. If a zone allows you to drill with 10 ppg up to 11. Okay, you drill. If it's going to jump to 15, you cannot drill starting with 10 and get to 15. You have too much overbalance. And when you have too much overbalance, you could have your pipe get stuck. So there's always a margin, we call it a drilling margin, which you want to tolerate. And if you drill it with a 10 ppg mode, for example, and you continue drilling, and you don't know that the next time you drill the next 100 feet, you're going to get to 15 ppg. You're not prepared. You have well control. The fluid, the well can flow. And when it flows, you have well control. It could lead to disaster. So that's why we say pressure regime is important. And then you consider which information you want to isolate. Now, for you to be able to determine whether you are good enough to be able to take your next drilling bit to the next casing shoe, you need to find the strength of the previous shoe, because at the end of the day, when you are drilling, your hole is as good as the last casing shoe. This is a very important point and very good question you brought up, this leak-up test. Your next hole section is as competent as your last casing shoe, and that's where we talked about. Remember, somebody was asking me about the shoe track. Why do we have shoe track? Why do we have float collar? I said it is very important for you to have shoe track because it's typically filled with cement to make sure you are isolated in case there is pressure beyond the shoe where you set the casing. If there's pressure there, it cannot flow back because there's cement and there's a check valve that does not allow it, just in case, because you never know. You never know. You stop, you think all is good, the well is not flowing, you set your casing, everybody's smiling, suddenly you see liquid bubbling inside your well head, and you say, what is going on? So you need to isolate. Good cement job is important. So why we do leak-off test? Leak-off test tells you the strength of your shoe, of the previous casing, to allow you how much more weight you can drill further to the next casing shoe. Am I good?
Yeah, thank you, sir.
Then the talk and drive.
Thank you, sir.
Okay, talk and drive. Yes, talk and drive. Talk and drive. Yeah, this is another component the drill engineer typically needs to be aware of. What torque and drag? When you say torque, means when your bit is rotating, you want to crush the rock so that you can get more hole drilled, so the cuttings can come to the surface. Now, as you're doing that, remember your pipe, your length of pipe is touching the wall of the formation. It's touching the casing inside the last casing, and then some part of it is in the open hole where you have new formation you've drilled. This pipe is rotating. As it's rotating, remember you have mud weight, you have mud in the hole, and you have cuttings. As this pipe is rotating, you want to know how much the pipe is sticking on the wall of the open hole and the casing. Sometimes not the problem in the casing, but in the open hole, the formation you have there, you have shell, you have limestone, you have carbonate, you have sandstone. You want to know how much stick. It's just like you put your hand in you are eating gari. Let's use gari for example. You put your hand inside your gari, right? It depends on how you prepare your gari. You can be able to cut the gari easily, put it in your soup. Sometimes the gari is sticking in your hand. You need to roll your hand very well for the gari to come out so you can put it in the soup. So torque and drag enables you to know how much stickiness your pipe is on the open hole, so that you don't want your pipe to be too sticky. Because if it's too sticky, when it's time for you to pull it out, it becomes a problem. And that's where you have, we call what? Stuck pipe. The pipe gets stuck. So we do that analysis depending on the mud, the quality of your mud, the type of pipe you run, what size. You need to design that to make sure that it doesn't, it's going to get sticky either way, but you minimize it. And when you do that torque and drag, it tells you to what point you should say, stop, it's time to change something. And you track it, you keep track of it. As you are drilling every 100 feet or half a stand or one joint, you check what is the value. These are values that are recorded. The torque is recorded on surface. So the driller or someone is taking note. At 2,000 feet, the torque is 5,000 foot-pounds. At 3,000 feet, the torque is 6,000 foot-pounds. At 8,000 feet, the torque is 20,000 foot-pounds. Oops, something has changed. Something has changed. You need to quickly, either you do back rimming, or you rim the hole, or you clean the hole. Take some time to circulate. Take some time to pump. Take some time to make sure the hole is clean, that you don't have cuttings in the hole, probably, which is causing that problem. So that's why you do tuck and drag.
Thank you, sir.
Okay, sir. Okay, sir. Can you hear me, sir?
Harry, we don't go to the. Oh, yeah, go ahead.
Just a quick one. I have enjoyed the lecture, and I just want to know about more about this directional drilling, especially these terminologies, the angle of inclination, angle of build, azimuth, magnetic knot, and then sometimes when they speak, they are building angle from center to center. So if it could be illustrated with a diagram or just explain, it would be okay. So I get on there. Thank you.
Okay. Okay. Let's start. Let's. So when you draw the again, my apologies to you again. I'm going by the slide here. I could have made some additional slide there, but again, it can depend on the cost. The cost limited us to show some few things. But your questions are valid. Now, if you look at the 4 cardinal points, right? If you draw a circle and you do your quadrants, right? The top is the north, which is 0. So you go clockwise. Clockwise is 90 degrees, and then you continue 180, 270, 360, right? So draw a circle, break it to 4 quadrants. Your north is 0 degrees. To your right, go clockwise, 90, 180, 270, 360. Okay, this shows you your azimuth. This is your azimuth. So as you are drilling, it's either they tell you, I want to be at azimuth of 90 degrees. So even though you're looking from, you're drilling, you are looking from stuff. It looks like your BHA, your line is straight. No, your line is actually moving at a particular quadrant. And as long as it's also in the quadrant, it also has an inclination. Inclination is draw a straight line and draw another line that deviates like a tangent. So draw a vertical line and draw a tangent. The angle between your vertical line and your tangent is your inclination. So the well is also deviated to a particular direction. So these are two key parameters that tells you your direction: azimuth and inclination. Azimuth and inclination. These are the 2 parameters that tells you where are you going. And typically the geologist, before we start to drill directional well, it gives us this as part of his target and tells you, I want 60 degrees well. That's the inclination. My azimuth is 120 or 90 degrees. The directional driller, that the gentleman asked, why do we need a directional driller? The directional driller have the tools to program in their toolbox to make sure that this is achieved. And that's how we get to where we need to go. And then talk about the target tolerance. I don't know if you asked me that. Target tolerance. Typically, the target, where your target is, could be very tight. They could tell you, I want 50 meters radius, meaning that if you go beyond that, you could be encroaching to some form of zones which is not conducive for them, especially for horizontal directional wells, where the reservoir thickness is very small. Some complex wells, the thickness is maybe 10 feet, 20 feet, not 100 feet where you can play around. So they give you a radius to say, if you stay within, we are okay. We don't want you to be bullseye. Bullseye means you are the middle of the target. That is it's very hard to achieve. That's why they said, I will give you a target tolerance. If you cannot give me the bullseye, stay within the bullseye 50 meters radius, which is about 150 feet. Stay within for me, I'm okay. Because they know the challenges of the tools. The tools are not, most companies are designing tools to meet this demand, but it's a challenge. But we know tools have uncertainty. So with tolerances, it helps to manage that. Is there anything else you asked me? I did not.
No, I think you have touched it, sir. You have touched all.
Sir, I have a question, please.
Remember, thank you.
Yeah, Mr. Sam. Yeah.
Yeah.
Okay, sir. From this slide that we're looking at right now, I see that the drilling went through a fault line. Now my question is this: is it safe or advisable to drill through a fault line Now, if, for example, this fault line, the whole production process has been concluded and we're producing, what happens in a situation where this fault line shifts, there's a movement of this fault? Because we know that place where there's a fault line, there's a possibility of a movement of those faults. Will the movement of the fault not affect the hole that we drilled? So is it advisable to drill through a fault line, like what is on the diagram right now, seeing that that's a fault?
Good question. Very good question. Now, typically, when the well is designed by the geologists preempt or attempt to preempt to tell us where the faults are. We try to avoid it. It's something not advisable to drill through faults. Couple of reasons. One of the reasons is you could drill through a fault and you can hit an over-pressurized zone, abnormally high pressure. So anyway, just a good point to bring up here. We have what is called normally pressured zone, abnormally pressured zone, okay? Normal pressure, abnormal pressure, and sometimes overly pressure. But just make it simple, normal and abnormal. Sometimes when you cut across the fault zone, you could find yourself to an abnormally high pressure zone where you are drilling with a given mud weight. Say, for example, you're drilling with 12 ppg mud, 12 pounds per gallon mud. And suddenly you cut across a fault. And behind that fault, actually, there's a high pressure zone. And suddenly your 12 ppg was good enough to drill, to hold the formation for conventional drilling. But suddenly you cross the fault, you now become underbalanced. That means the pressure at the other side is more, and then the well wants to flow, and what do you do quickly? You have to shut in the well and kill the well. You close your BOPs. So that's a danger spot. But typically, what happens is when we see fault and we cannot avoid it, what we try to do is we manage it. Yes, if we have a good study, we can always take care of the fault and ensure that the issues that we encounter, we manage it properly. And at the end of the day, guess what? We will not produce from the fault. At the end of the day, we're going to run casing. If we can secure and manage that fault and drill through it with all the necessary technology and knowledge we have, we will run casing and we'll cement. So when we cement, the fault is behind us, so the problem is solved. Okay? So that's what typically we do. So we are aware of that, and it's a concern. But the practice is we try to drill directionally, staying away from a fault. But if we cannot avoid it, we will manage it and get ourselves through with the technology available and secure the well.
Okay, so from what you're saying, sir, after the casing is run, the movement of the faults will not affect the casing?
No, it doesn't have a fault. A fault is not a formation. It's a formation itself. It's a formation you're drilling through. It's a formation. So you just drill through the formation and you cut across it. And then you state your casing here. It's just that when you cut through a fault, you could see some losses. You could have losses, and you could have the opposite, well controlled, the well can flow on you. But at the end of the day, drilling engineers and drillers, this is where we are good at, and we take care of that.
Okay, sir. Thank you, sir.
Hello. Yeah.
I just want to ask two questions. When preparing the truck and drag, how can we interpret the plot for the truck and drag? Then secondly, I also want you to throw more light on whip stock. Hello, sir.
Hello.
Yes.
Quickly go to your question. We need to go to the next slide. I need to wrap up. Mr. Frikat is waiting. Go ahead. Hello?
Can you hear me?
Yes, go ahead. Quickly, go ahead.
I said, how can we interpret the plots on the graph for the talk and drag? And secondly, I want you to throw more light on the whip stock process.
Yeah, for the talk and drag, you interpret it by we do what they call a baseline. There's a baseline to say if the well is drilled successfully. Again, we typically use offset data because for you to be able to tell how information is behaving, we need to have had some history. So we go back to the history, we call it offset wells. We see how that same well was drilled and look at how the values. We take those values and we make a plot and say at this depth, we expect the torque to be maybe 10,000 foot-pounds. Now, when we start drilling, start to monitor. We give you some what they call constants, some variables, constant and variables. And we said, okay, at this depth, we expect to see 5,000 foot-pounds. But when we started drilling, we saw 6,000. It raises a concern, and that's a concern. So we said, okay, maybe it's some one-off stuff. We clean the hole, we continue drilling, and it goes to 7,000 pounds. And we check the offset. Our planning says it should be 3,000. Now we are seeing 7,000. It means something is going wrong. So at that point, there needs to be a conversation between the driller, the company man, and the engineer. And then we figure out what is going on. It's either we need to do something different in the hole. And typically what you have is you could pump some very light fluid like lube oil to try and minimize that drag. Something is dragging you in the hole. So you pump that and you continue drilling and you continue to monitor the value. If it gets so severe, you may have to come out of hole, pull out of hole, and go with a different BHA to try and address the issue. On your second question, whipstock. A whipstock is a specialized assembly. Again, there are different types, mechanical, hydraulic. Very rare these days, we use whipstock for directional drilling. But typically, if you have drilled a well before and the well is not producing anymore and you want to target a different zone, the geologist says, this well has been producing for 10 years. The production has dropped. We want to go to a different zone and you don't want to drill a new well. We go in, get a suitable spot for the whipstock. You set it in and you mill a window inside casing. Whipstock typically are meant to punch hole inside the casing. And when you punch the hole inside the casing, you can come out of that casing and you have a new directional profile to drill into a new target. Is that your question answered? Hello? Hello?
Hello, sir. I can hear. I can hear you, sir.
All right. Okay. Let's move on. I know you have a lot of questions. I've just been told by Globat team to wrap up, but I need to go to my next slide, which is rig equipment. But I'm sure that's something we can just talk about briefly. Nothing. I'll make sure he sends you the. I got some video there to share with you, so hopefully he may be able to share that with you. All right. So let's talk about rig equipment here. Gentlemen, thank you for your patience. I know we spent more than 3 hours here. I'm supposed to be limited to 3 hours, but I told you I'm going to talk a lot, so I've overseeded my timing. But your questions were very, very, very entertaining, and not entertaining, I say, but very educative and very informative. So I appreciate that. So let me just go to the key points here. Talk about rig equipment. You can see my slide. Can you see my slides?
Yes, we can see it.
Yes, sir, we can see it, sir.
Hello?
We can see the slide, sir.
We can see your slide.
Okay. We can leave this out then. Okay. I'll just inform the student about that. I'm just inform the student and let them know that this slide will be taken off. Yes, they can go break. Okay. All right. Thank you. Okay. Okay, ladies and gentlemen. Hello.
I hear you, sir.
Yes, gentlemen, I've just been informed that staff presenter Dr. Srikat that is going to take you on drilling rigs is just at standby. So as a result, and the time limit, this drilling equipment will have to be suspended. However, you get back with the global scale, but I will take the last 5 minutes for questions. I think your questions are more important actually. So if anything you want to ask me before I sign off here, and hopefully I can get back to global scale to get you some good quiz. Hopefully you come back. If you find this useful, let global scale know about it and tell them what you've learned, and we'll take it from there. Hopefully, I wish you all the best in your careers. Hopefully this is not the last time I'll be able to share with you my knowledge or my skills and my expertise on this field. So for that reason, I would say I would like to take questions on the last two topics we've just talked about: introduction to drilling and then directional drilling. So if you have any other thing in your mind, anything in your mind you want to ask me, let's take the last 5 minutes here. I would like to address it, and then we'll wrap it here, and then I will hand it back to Global Skills for your next instructor. Is that fine with you all? Is that okay?
Yes, sir. Yes, sir.
Okay. All right.
I have a question, sir.
Yes, go ahead.
Okay, sir. Fine. I'm a drill logistic engineer, and I come across most of this equipment when they arrive on the field. So I have this question to ask. There's what we call non-magnetic drill cooler and non-magnetic heavyweight on your BHA. When we talk about BHA, we call non-magnetic drill cooler and non-magnetic heavyweight. Can you please explain about the non-magnetic drill cooler and non-magnetic heavyweight?
Yeah, one of the challenges in drilling a well is because, especially when you're drilling and you have a lot of pipe in the hole, right? You have casing already in the well, and as you drill, you keep setting casing, and also nearby, if it's a development well, you have a lot of wells in the surrounding. We want to try and minimize, because the more there's interference with magnetic field, it tends to affect your tools, especially directional tools. Most times you have those non-magnetic drill collars when you have directional tools in the hole, like MWD, gamma ray, resistivity. We try to separate them from each other. We keep distances from when the signal is sent and then the receivers. So that's why you have those non-magnetic, because magnetism, as you know, back in school, there's always a field, magnetic field, which tends to affect your tools. So because of that, they need to add that to take care of it.
All right, sir. Thank you, sir.
Any other question? Okay, it looks like we have exhausted the question. So once again, let me appreciate you all for your timing. Thank you for your patience. I know I've taken a lot longer than your time. Some of you have data you're using to listen to this Zoom call. But thank you again. I want to appreciate and say thank you. And hopefully we'll get in touch again in the future and get back to Global Scale. I'll prepare your quiz. Hopefully the quiz is going to be 1, 2, 3, something easy for you to do, and try and also sign up for a certificate. That gives me the pleasure to say, yes, you like my course. Okay. Thank you very much. Okay. So I hand it over back to Global Scale. All right. Thank you all.
Guys. Thank you, Engineer Joe. I trust that you all have gotten something from the first session of this the drilling engineering course, introductory course. Please stay logged on as Dr. Srikat, your next instructor, will be joining. Just stay logged in. he's supposed to come in by 12 p.m. So you can take the remaining 3 minutes to maybe grab a quick drink or something. By 12, he would join the meeting. He's already on board. He will join the meeting by 12. So stay logged on while your next instructor comes on.
Okay. Good morning. Good morning, gentlemen.
Good morning, sir.
Good morning, sir. Dr. Stevens, good morning.
Yeah, good morning. So I'm a bit late because you saw now I'm in US here. It's only in the morning, so I'm a bit late. Anyway, I think please keep your mute. Somebody, there is some disturbance from background. I don't know who is. Please keep everything mute. So just listen to me. So there's no any disturbance from background. Okay. So today we'll be discussing about the today you must have in the last 3 classes somebody must have told you about the mud system and other details about the drilling. Of course, drilling is a very big subject. This is just introductory subjects on drilling. So before I start, let me introduce myself. I am in the drilling industry for the last, I worked in the drilling industry for about 4 decades. Then I retired from the industry in 2017. Then I am with the Globat and some other places also, imparting training. I've worked both in India and Middle East and Libya, some of the countries. Okay. So today we'll be discussing when you try to drill it well, naturally need some instruments, some equipments, everything. So drilling rig is the most important equipment. Whenever you think of drilling a well, you need a rig, whether it's a oil well or a water well. You must have seen some of the water wells being drilled in your area. They come with a small truck mounted rig and just drill the water well. Just water well maybe 100 feet, 200 feet, 300 feet. It's not very deep. So, but drilling rig, we need to have a different type of drilling rig. So we'll be discussing those things one by one. So this is basically a drilling rig. It looks like this one. You see here, this is called a catwalk. The one is here, and you find very typical name in the drilling rig. Something is like a doghouse, catwalk, monkey board. So it's not the catwalk for the fashion catwalk. It's not fashion catwalk. It's a catwalk. So what happens? You find such names here. Anyway, these are the names people in our industry, and this is these are the drill pipes here. Drill pipes are all mounted here. Then you have the Cali here. I'll show you. This is the mast. So they call this thing the mast. Okay. So this is basically a drilling rig, and here mud system must have studied about this one also. So, so this rigs is which the photograph that I showed is a land rig. So use such type of rigs for drilling in the land, not on offshore. And these rigs you can disassemble the rig. Okay, you put everything. The mast is into 2 parts sometimes. Then you have the floor, everything you disassemble, then you transport it from one location to another location, again assemble it here, okay, and again put it there and start drilling. Once the drilling is over, again you take it to another 3rd place. So every time you move, you have to disassemble the rig, then reassemble it. So, and these rigs, so again we go back to this one. You see, these rigs again depends on how many depth. What is the depth of the well? It's a deep well, you need a bigger rig. It's a smaller, less depth well, you can need a smaller rig. Because it depends on the capacity of the engine, the drawworks, and the size of the rig. Okay. So there are different types of rigs based on your requirement. You have to select the right type of rig to drill a well. If you are going to drill a very deep well, you have to a bigger rig, and a smaller well. There are workover rigs also, so you can do that. Then what are there in the rig? What are there in the land rig? One is called a derrick. Derrick means a tall steel structure that houses most of the drilling tools and equipments. It provides the necessary height to handle the length of the drilled end collars. If you again go back to the photograph here, so this whole thing is called a derrick, and here is called a derrick floor. The whole thing is called a derrick with the mast. This is called the mast. The one is standing here, and these are the drill pipes. So the drill pipes are put here. They have to. This is called a monkey board. This one is called a monkey board here. So they put the drill pipe here like this. Okay. So when they drill, after they have to take the drill pipe, put it inside the well. Again, they pull out and they have to stand it. And they call it stand. Every stand has two pipes. You don't find only one pipe. There are two pipes here. If you see the joints here. So two pipe joints together to make one stand. Okay. And the length of the pipes are around some 12 meters, 12, 13 meters, depending. There are some smaller size of rigs, pipes also, bigger, longer pipes, smaller pipes, different types of pipes, heavyweight pipes. So depending on this thing, they have to make, and supposing they want a smaller pipe, they can adjust this monkey board also, okay? Then their movability can be, sorry, yeah. So this is called the derrick. And there is a floor, drill floor, or some people call it derrick floor, some people call it drill floor. And the area at the base of the derrick for the drilling operations contain the rotary table, galley, and drill string. So here is the floor. If you go back again, this is the floor. This is a house where the driller sits, and this is the floor. In the floor, they have to keep this thing standing like this, and you have the rotary table where you rotate, and galley, everything is there. So the area where you have this floor, then in this derrick floor, you have a rotary table which rotates, because when you drill, you need to rotate the drill string. So you have to rotate the bit. So there is a called a rotary table. So rotate the drill bit at the bottom of the hole. Modern rigs have used a top drive instead. You see, nowadays they are rotating. In the early days when they started drilling, they used to have a rotary table on the derrick floor. So they put this Kelly, I also use a 6 hexagonal type of pipe. It's not a round pipe, they're hexagonal, 6 faces. So when they used to drill, they rotate the table, and naturally the bit also rotates. But nowadays they have different systems. One is called a top drive. They put the drive at the top, just on the below the hook. There is a motor. Sometimes they call it mud motors. They put this motor inside the hole, just above the bit. So when the mud falls on this motor, it rotates, and in turn rotates the bit. So rotation is how you are going to rotate it. Either you rotate it using a top drive, or you rotate it using the drill table, the rotary table, or you can use a mud motor. And for the safety reason, we have to have a safety. Why the safety? Because when you start drilling, and supposing if you are not you have not maintained a right mud weight, in that case, sometimes what happens, because of if the formation pressure is high than the hydrostatic head, that's the mud weight. So some of these fluid from the formation, like gas and oil, can come into the hole. And if you cannot control that, because in high pressure it comes, you don't control it, then you land up in a blowout condition when the whole gas and liquid comes out of the well, and sometimes catches fire also. So to prevent that blowout condition, we need to have a blowout preventer. And it is at the top of the well. It is fixed on the top of the well. That's called the blowout preventer. Somebody must have taught you how you are going to fix a blowout preventer. Then you have to first dig a hole, then lower your first casing like this. Then you have to put the blowout preventer over that. And there are different types of blowout preventers also. Depending on the formation pressure, we decide how much, what is the standard of the drill blowout preventer. Okay. Then in the land rig also you have the mud system. And you see, if you go to any rig, you find the maximum place is occupied by the mud system. In the mud system, you have the tanks, mud tanks. There may be, depending on the well you are going to drill and the volume of mud they need, you can have like at least 4 tanks, 5 tanks. Okay, out of those 4 or 5 tanks, One is a active tank from where you suck the mud. Then you have a reserve tank also. Sometimes you can have 2 reserve tanks. Okay, if you are reserve tank, some of the reserve tank we keep a heavy mud weight. If by chance there is a bloat condition, they can use this heavy mud weight. So these are the different things in the mud. First the tanks, then you have the pumps, then you have other equipments on the mud system. But the other equipment is this solid control equipment by descender, desilter, degasser. Then you have the sail seeker screens. Okay, so all these things are there on the contained mud system. And if you know something about drilling fluid, and if you are going to attend the classes, all the classes that are 3 modules, you attend all the modules, you can know what is the purpose of the drilling mud. But basically, roughly speaking, it is the first thing, it brings the cutting from the, when you drill, you generate cutting, and those cuttings will come to the surface. The drilling mud brings it to the surface, and then it cools the bit, and also it lubricate the bits. The basic thing, there are many more purpose for the use of the mud system. So mud system occupies the maximum space in the drilling rig. The rig is standing, then you have the mud system. Here, of course, I don't know, you can see here, this other side, you see this one, here is the mud system on the base, on the ground, the mud system here. Okay. Then you have the power system. Power system, you need to rotate the drill table and to pull out the string, send the string. For all these things, you need energy, you need power. So you can have a diesel engine generating. You can sometimes, some people, electrical rigs are there where they generate electricity and use the electricity for all this work. And in some places, they don't the electricity directly, they use the power from the engine to rotate the drill table and drawworks, everything. And then you have a drawworks there. Drawworks mean which draw the works. So it is like a drum. In the drum, you have the cable rotated there, and then this cable attached to a, if you go back here, see here, there is a drawworks here, this side, the whole thing goes to there, a pulley on the top, and then it comes down here, and then what happens, you can hang it. So for taking it down and bringing it up, you need those drawworks for the string to pull out and running in. So that's the drawworks drum is there. So a winch mechanism located on the drilling floor used for hoisting equipment in and out of the well. So running in and pull out. That means when you are going to drill a well, you need to have a bit, the drill pipe, the whole thing has to go inside. So when you need a mechanism, a power to take it out and get it in. So that's called in drilling terms, we call it pulling, pull out and pulling in. Okay. POH, pulling out of the hole and running in. So these are the 2 things they use, running in the hole, RIH, and pulling out of the hole, POOH. So these are the terminology used. So when you put this drill string inside the well, we call it running in. When you bring out the whole thing, you call it pull out. So for doing these things, you need some energy. So there is a drum type of thing called a drawworks. And you see, if you visit a rig, things will be more clear. If possible, it's better try to visit a rig. And then what happens in the land also, these are the things, the basic parts in the rig. So basic part is you have the drill floor, you have the rotary table, you have the drawworks, okay, have the BOP, okay. So these things are there. And one more thing I'll tell you, this board, this place is called a monkey board, where normally a top man stands here, and then when they pull out, they pull this thing and stack it like this. Somebody stands here, they call it a monkey board. So there are different types of land rigs. one is the conventional rig. The one I show you is a conventional rig. Okay, that assembled piece by piece in location. So you disassemble and then reassemble it. There is another rig called a slant rigs. Of course, it's a new thing. And these rigs drill at angle. So if you want to drill a horizontal well or an angled well, you can use this type of rig, which can be useful for accessing reservoirs situated at an angle or for drilling multiples on a single location. So what happens if you have this type of rig, you can drill here, this side like this, a slanting rigs they call it. And the third one is called a mobile rigs. That means these are truck mounted rigs. You see, in this case, in a conventional rig, what you do after you finish a well, you have to disassemble the rig. You have to remove all the parts that the mast, that's called the mast. The one is standing is called the mast. So you have to, there are 3 pieces in the mast. So you have to disassemble all the 3 pieces, disassemble the tanks, everything. Then you have to go to a new location and again reassemble here. But there are some rigs called truck mounted rigs. The whole rigs are mounted in truck. So you take it to a location and the whole rig can stand like this. Okay. But these rigs are basically used for a shallow well or workover well, because you cannot mount a heavy rig on a truck, the whole rig. So naturally, these rigs are for smaller holes, not deep holes, or maybe used for workover job. Okay. Then you have the offshore rig. So first is the one is we call about the on land. So we drill wells in the on land as well as in the offshore. We go to the sea and drill the well there. So this rig, which you saw in the picture, is the land rig where you drill the well on the land rig. So naturally, if you want to go to an offshore location, you cannot take this rig there. You need a separate type of rig which should be float there. Okay. So in the offshore, what happens? Sometimes they have a fixed platform or mobile. Okay. So either you have a fixed platform rig or a mobile type of rigs. And these rigs can be like moved from one location to another by a ship can pull it. There are some self-driven type of thing. There are some rigs which can pull. It's only some other ship pulls it. So out of these rigs, you have the floating units and bottom supported. That means some rigs are standing on the sea floor. Some rigs floats on the sea water. Okay. So bottom supported, they are supported by the seabed floor as they come in contact with it. They can only be used for shallow water depth. So it is supported. So what happens? There are legs are there. It stands on its leg. They call it jack-up type of rig. It's supported on the bottom. And where it's a deeper water, you cannot put something standing on. There are 3 jacks are there, 3 legs are there. It stands on these 3 legs. But if you go to deeper water, you cannot use this leg, because if you have a very, very long leg, then your center of gravity will go up. So the rig cannot stand there. It can tumble down. So that's what happens. There are some units which floats on the water, the deeper water. So if you go to deeper water, you need a floating type of unit, not the bottom supported unit where it stands on the land. They can be used for drilling deep water depth as they are floating. They can be supported on large pontoon like structures submerged. So what happens? They are floating type of thing. They floats on water, so you can drill it if you're going for a deeper water where the water depth is more than about maybe some 200 feet, 300 feet. If more than that, you cannot have a jack-up type of thing. You need a supporting, the floating type of thing. And this is called a inlet barge rigs. What is this one? You see what happens? To take a ship, suppose you want to take a ship, because out of these 2 rigs, some of the rigs, as I told you, self-propelled type of, that means there is ship itself is a ship with a rig that is self-propelled. Some rigs are not self-propelled, they are pulled by another ship to a new location. So you're drilling here, you want to go to a new location, one ship will come and then pull it and take it to a new location. And some places they're self-propelled, they itself is a ship, so the whole ship will move. But for moving those ships with these heavy weights, you need water. Otherwise, how it will move? But in some cases where you have these very, very shallow water, okay, maybe a river, maybe a small water depth, you cannot bring a ship here. You see these places, you cannot bring a ship here. So here what they do, they use the barge type of thing. So it's just a platform and they put the rig here. This whole barge can move in a shallow water also. So depending requirement, of course, nowadays what they're doing, instead of bringing these rigs here, they can drill a well here and make a deviated hole. But depends on the situation. In one case, as I understand, in Middle East, when I was working there, we have such a thing. So instead of taking a rig, they fill up these places and made an artificial island type of thing and started drilling there. Then this is a barge hall with drilling rig placed on a barge deck. They're used to drill oil on shallow water. The shallow waters area could be swamps, lakes, rivers, canals, anywhere. They are a cross between onshore rigs and offshore drilling platform, providing solution for locations that are too deep to be drilled with land rigs but too shallow or shelter for large offshore rigs. So this water depth, you cannot put a land rig there because it is some water is there, and you cannot take a boat or ship there. So you have to need a barge type of rigs, inland barge rigs. And what are the key features? At its core, the rig is built on a barge-like structure which can be floated to the drill site. Once it reaches the desired location, it's the rest of the bottom. The rig is then deblasted, water is pumped out, raised above the waterline. What happens when you are stuck it there? They just fill water. There are some balloon type of things, they fill water. So when on the water weight, it goes down. Once its job is done, then they remove the water, so it starts floating, that type of thing. And inland barge rigs are designed for water depth, typically ranging from few feet up to 20 feet, although some cases operate in a slightly deeper waters. And many inland barge rigs are modular design, allowing to be disassembled. These barge rigs sometimes modular means you can disassemble it and reassemble it, like other rigs. Here also you can do the same thing. So you take the barge first, then bring the rig over there, then assemble it, and you can start drilling. In some cases, the whole rig you can shift on a barge without disassemble or reassemble is not needed. You can bring the whole thing to the location. Okay. Then some inland barge rigs come equipped with jacking system that allow the drilling platform to be raised above the barge deck. Similarly, called the offshore jackup rigs, some of the barge rigs. This feature can be useful in a prone to flooding or tidal variations. If there is a flood, suppose you are working on a place, there is a river, the water comes, so you can raise it or you can take it down depending on the water. And due to the ability to be disassembled, transported with a minimum ground disturbance, inland barge rigs are often used to good choice for drilling environmentally sensitive areas. So what happens, supposing, as I told you, now if you go back to the photograph here, now there are forests here. So if you are going to have a land rig there, then you have to disturb the whole thing, whole ecology can be disturbed. You have to cut the forest, cut the trees, and make roads. For all these things, you have to disturb the environment. So without disturbing the environment, you can just bring a rig in the canal or a small waterways and then start drilling. So you are not disturbing any of these things. You are not disturbing the trees, not cutting the trees, making roads, anything. Okay, so it's for that environmentally sensitive areas you can use this one. And just like other drilling platforms, inland barge rigs are equipped with a range of safety systems. Same thing. Any rig, whether it is an offshore rig, onshore rig, barge rig, any rig, you have to have these blowout preventer and other safety systems. Where you are going to locate it. It's not that bird jig, there is nothing, something's missing there. In the bird jigs also you have the mud system, you have the blowout preventer. Same in the offshore is also same thing. In the land is also same thing. Everything is same. Only how you are going to put the rig in, depending on your requirement, you design the rig. If you want to drill in the land, you have a land rig. Sometimes you are going to drill a shallow well, you can have a truck mounted rig. If you are going to drill in a shallow water, then you have the birch type of things. And if you want to drill in an onshore, offshore, you have to have a jack-up or floater type of things. So it depends on your requirement, select which type of rig you are going to use. But rest of the system, the rig, like the drawworks or rotary table and the BOP, the mud system, everything is same. Okay, there is no change, not that something is missing there, everything is there. And these birds are primarily used in the exploration and production of gas reserves located beneath the freshwater lakes, rivers, and marshy and swampy land. And they can be found in US Gulf Coast, Niger Delta, and Africa, if you guys are there, and parts of Southeast Asia, where you have the tropical areas, forests, jungles, shallow waters are there, where you cannot take these the risks. And in conclusion, inland bird jigs provide a niche solution in the drilling, allowing operator to access reserve that might be difficult, impossible. So this bird jigs actually has solved a lot of the problem when this concept was not there. So naturally, either in that case, you don't drill in those places, or they have to fill up the whole water body and then make a island type of things, and they started drilling, or you have to bring the rig and drill it deviated well. Those things you need to do. So for that, you are going to disturb the environment. And if there are a lot of wells to be drilled in the particular type of body, water body, then becomes a problem. So bird jigs is helping us in drilling a well without disturbing the environment. Okay. So this is called a jack-up rig. You see, this is these are the three legs are here. You can see this. There are three legs, like a jack. Why they call it jack-up? They call it jack. So when this rig moves from one location, this jack is up here. Now it's going to move. Okay. So whole jack will up, and this thing will float. The whole thing will float once the jack will come to the top. And this is not a self-propelled type of rig. So what happens? This will be pulled by a ship. Sometimes 2-3 ships, they pull it, boat, not big ships. Sometimes 3 boats, supply boats, they pull it and take to the location. So once they reach the location, then these jacks are lowered into the water. Okay. And when they touch the sea floor, it stands on the sea floor, these things. So the 3 legs are here. It stands on the 3 legs. So while lowering these jacks, they have to see it should not tilt. So they have to lower all 3 legs together. Otherwise, what happens? Suppose one leg goes down and another 2 legs up, so the rig will tilt and can go inside the water. So this is another process of jacking the rig. So there are experts for that. To jack the rig. So it's like in a car, you have a jack you raise your car to fix the wheel or remove the wheel, you have a jack. Same thing here, they call it jack up. So you have 3 legs and stand on that one. So there are coming to drilling rig, a floating birch with long support legs that can be raised or lowered independently. Okay. They contain crew quarters, and you see whenever in onshore, what happens? People stay, maybe if it is near to the city or town or villages, people stay in their town and villages. They can travel from there to other locations. And sometimes they have a living areas near the rig also, if it is a remote type of location. Here also people has to stay here. So here you have the whole thing in one place. Like you see, this whole thing in the one place. You have the rig. This one is a helipad because the crew member has to be transported from the land to the rig. So they need a helicopter. They come with a helicopter. So it's a helipad here. This is the rig. These are the 3 jacks or 3 legs. And here you have whole thing, the mud system, derrick floor, everything is here. And also here you have the living quarters where the crew stays there because every day they cannot come and go back. So they stay there for maybe 40 days, 28 days, a month, depending on the particular contract the company have. But there are some international rules are there that you cannot keep someone in the water for maybe, I don't know what the rules, some rules are there. Because when I was working in India and also in other places, we have 14 days rule. You stay 14 days, then come back. Okay. So the living quarters, everything is there. You have the quarters, the bed, everything. Then there are also some food. There are some catering system is there. So food is prepared. People eat there. But you have to stay only in this area for 14 or 28 days when you are member of the crew, and you cannot go out of it after the required time, 14 days or 28 days. Then only you leave this place and come back to the land and meet your family members. Okay, otherwise you are in the sea itself in a very confined space. But here particularly because it's a tough job staying on the offshore, the payments, the salary are a bit higher as compared to you get some company they give some offshore allowance separately. Some company have a better package if they wanted the offshore location. And as I told you, you have the heliport cranes to move to location. They are towed by boats, but jackup would have to be, that's what I told you. On a new location, the legs are again jacked up. So this jackup can reach depth up to 600 feet. As I told you, is about 200 meters. For jackup rigs, surface BOPs are used. And here what happens, they use the BOP on the surface here, not on the underwater. Here they use it. But of course, in deep water, they use it underwater. But for this jackup type of thing, they use it on the surface, BOP. And here what happens, you can drill several wells for the same location. Now you bring a rig, okay, then you start drilling. So you can drilling deviated wells, several wells from the same location, just deviated wells from the same location. And here also it's very easy in the sense that suppose you want to, like shifting a rig in the land is quite expensive because you need to have a proper road. You need to a whole lot of crew. Logistics is a very important thing. A whole lot of what you call the trucks. You have to disassemble this thing, then again load it on the truck, take it to a new location. There again you reassemble it. And here what happens? You can just pull it. You now this jackup, you put the jackup up, put the jacks up, pull it another location. There again jack it down. Everything will be in the same place. Your mast will be standing. You don't have to disassemble anything. In other places, what to disassemble the mast, you have to disassemble. You have to clean the tank, disassemble throw everything, disassemble the tanks. Each tanks are attached. Disassemble the pump, disassemble the motor, engine, everything you have to disassemble piece by piece and take it. Here what happens, everything one place, so you just pull it. So don't have to disassemble anything here. That's the easy thing if in the offshore rigs. Then the key feature leg, the defining feature of jackup rigs is legs which can be raised, lowered. These legs are extended down to seabed while main platform is jacked up above the water surface. So you have to take it down and stands on the seabed, and the whole thing is lifted up from the water. And how much you have to lift, that's also another thing. You see, they have to lift it to certain heights. They have to give some air gap. Now, if suppose the rig is touching the water, then if there's a tide, the whole water will come into the rig. That's why they raise the whole platform above the water surface. Okay. And then what happens if there's a tide also, it cannot. For that, they have to find out what is the average tide that comes there. What is the height of this tide? Is 20 feet, 30 feet, 40 feet, how much it comes? So accordingly, they can raise that many feet from the sea surface. Otherwise, the water will rush into the rig and it will disturb everything. Hull. The hull houses the drilling area, crew quarters, machinery, drilling mode. The hull is elevated above the sea to provide stable work environment isolated from the wave action. This is called the hull, this one. Here you have the living quarters and everything is the offices, crew people, they stay here. This is called the hull. And then, yeah. Then what happens? This jack, the legs, can have different footings. Footings, they can have a mat type, means all the 3 legs, there's a mat. All the 3 legs there's a mat, it goes and stand on the seafloor. And in some cases, and has a large hollow slab that is set on the seabed and the rig is jacked up above it. That's the thing. But in independent leg, the 3 legs are independently, they can stand. So there's a mat where there is a type of a slab. On the slab, these things are there, or you can have the different. And it depends on the condition of the seabed. Okay. Like I can tell you, is supposing seabed is not smooth, there may be a mountain type of thing. There, this slab will not work. Okay, if the seabed is smooth, this mat type of thing can work. But in one place in India, in the offshore, we had a rig. It was on the submerged mountain. So if in the submerged mountain, you cannot have this mat. You have to have this the independent jack. So one leg can be down this much, one can be down longer, depending on if the bed is not smooth, it's a slanting type of bed. So there the mat will not work. There you have to have the independent leg design. Then in the transport, the legs are raised. When you are transporting, you have to raise the leg because the legs are standing, you have to raise it and then you pull it. Okay. And once the desired location is reached, the legs are again lowered in the seabed. Then again, you start your drilling operations there. Okay. And advantage of this is that stability. So jack-up rigs is like a normal land rig. It's standing one place, not moving like this. They're standing on its leg. So it's stable. Okay. And like a land rig, land is stable. Here also it's standing on its leg. And if there is a rough sea and there's a lot of wave comes, nothing happens standing there. Okay. And being self-elevating, they can be relocated relatively easily. As I told you, you can just pull it, you raise the leg, then pull it, new location, and down the leg. That you can do. And for shallow water operations, these are quite cost-effective. Shallow water means one is the very, very shallow water, which is you need to have a berth. One is the land where you need a land rigs. Where is water is very shallow, you need a berth. Where is the water is not very deep, you can have a jack-up type of rig. Then there is one called is submersible rigs. You see where the water depth is very, very too much. In that case, what will happen? You cannot stand on the jack. So these are the submersible rigs. Here what happens? I can tell you, there are some heavy things and they pour water. Like in the barge, you have seen that they pour water, but it touches the ground. Here it doesn't touches the ground. It just goes down. And because there are a lot of heavy things on the bottom, so the movements of the rig is restricted there. It cannot just float like this. Okay. If you have seen that a small boat can easily float, but a big ship is not very difficult for the big ship to float like this. So the rest of the rig floor, they are used for shallow water depth. On arrival location, buoyancy tanks are filled with water. There are tanks which filled with water. This caused these to sink until it sits on the sea floor bed. There are two type of things here. One is the floating type of rigs. One is submersible. They have these tanks. They sit on the rig floor. Jackup is the long legs. So depending on different, you see where you can take a barge, where you can take a submersible rig, where you can take a jackup rig, where you can take a floater type of thing. So this floats there, after which it can be towed to a new location. So here what happened in the buoyancy tank, you feel water. So when you feel water, it will, because of the heavy thing, it set down. Once your job is done, then you remove the water, it starts floating, take another location. So these are large hollow structures that provide buoyancy when the rig needs to be moved. By flooding these columns with water, the rig submerged and rest on the seabed during drilling operations. Relocate the rig, columns are de-blasted, water is pumped out, and then it starts floating. And this is why the drilling operation takes place. The deck, already I have told you, the same thing, everything in the rig is same, whether land rig, the deck is there, rotatable is there, the mast is there, monkey board, everything is same. Only how you are going to put the rig in what place. If it's a landing, you just take it on the land rig. It's a very, very shallow water, you can use a barge. If a bigger, more water depth, you can use a jack. If some water is I can see is less than jack or more than the barge, then you can use this type of some submersible rig. So different type of place you can use the rig, and you have to select which one you are going to use it. And in this floating boat, the submersible rigs can be towed to a desired location using tugboats. Same thing is submersible rigs or any rig, tugboats are there. As I told you, some of the rigs are self-propelled rigs. It's mounted, there's a ship and it is on the ship. So it's self-propelled. And some of the rigs are not most of the rigs are not self-propelled, because for that you need to have a ship with everything, every engine. For running the ship, you need like a ship. So it's expensive. So instead of, it's better to tow these things. So they can tow these rigs to a new location. Okay, they tie with boats and the boat will pull this thing and take to a new location. Once the drill site, they again is a buoyancy and you can drill. With the rig stabilized in the ocean floor, drilling operations can be commenced. So you can start the drilling. On this floor, it's the rig is on the surface of water. The rig floor, everything, but it stands because the buoyancy things. If you can see the rig here, the photograph, these are the buoyancy, these things are there. There are, you see 1, 2, 3, 4, 5, these things are there. It sits on this rig floor. Then being on the ocean floor provides a high degree of stability, naturally, like a jackup rig. Only thing is that jackup, the long one, so you have stability more. And submersible rigs are primarily designed for shallow waters, typically 50 feet deep water, make it suitable for specific geographical locations. So depending on this thing, you can use this one. Then there is another called semi-submersible. And you see here, semi-submersible rigs are this one, where you see this one. This is semi-submersible. So it is like a floating type thing. It floats. And they are self-propelled floating vessels. Semi-submersible, what happens? It is very deep water, you have to use it. They can be used for drilling, workover, and as production platforms. They supported large pontoon-like structures submerged below the surface. Okay. And the pontoon can be used for storage. The operating decks are elevated on steel columns, roughly 100 feet and more above the pontoons. These are the pontoons. These are the pontoons. Okay. And you see, this is the sea floor here. Right. And they operate on a wide range of water depths. They have 6 to 12 anchors tethered by strong chains and wire cables used to maintain the position. So they have, in the jackup, you have the legs here, they have the anchors, like any other ship, you know, they have the anchors. There are chains. So the chains you can have 6 to 12 anchors are there. So lower this thing, and then it is the anchor, they have a teeth type of thing. It just holds the sea floor so that this will not move like this. In a jack-up, you are standing on, so there is no chance of moving. See, it's a floating type of thing, it can float. So in that case, you have to have these anchors there so it will not move here and there. They also utilize dynamic position system with computer controlled thrusters. And here what happens, even if the anchor is there, maybe there is some movement will be there. So they can have some dynamic positions of they fill some water on this thing. So if it moves like this, because the water, it can be like this, it can be like this. So there is called a dynamic position system. You can find this thing many of these boats also. And here what happens, because the water depth is more there, so instead of putting the BOP on the floor, they put it on the direct floor, they put it on the sea floor. And for if you attend a class on deep water, in the deep water drilling, you see what happens if your the BOP and other things on the floor, direct floor, it's easy for you to maneuver it, operate it. But if it is on this sea floor and sometimes in deep water, in the deep water, what happens is not possible. In other places, shallow water, you can send a divers. They call the deep sea divers. The divers can go inside and do the job. But here what happens, you cannot send a divers. So in these cases, the BOP is operated from the surface. And if there is some problem, you have called a ROV, that is remote operating vehicle. So they lower the ROV and this robot type of thing, and this can go and do the job at the bottom of the sea floor, and you can monitor it from the surface. So that's called it, sometimes in deep water, they use this one. And semi-submerged rigs have large pontoon-like structures or columns that provide buoyancy. These columns are partially submerged during operation, which gives the rig its name and also provides stability. And same thing, the operation area is same in every places. Only the thing is that in land rig, there's a difference between landing and offshore rigs. That in the land rig, you have the direct floor, and then most of the tanks are on the same place, just around it. But in offshore, because it's a small area, okay, so in this case, what happens, the tanks are below the deck. The mud tanks are below the deck. Okay, you cannot, there is not sufficient space on the floor to put the tanks, it's below the deck. And also some places, the storage area is not much. Okay, in the onshore, you have a lot of land, you can put your warehouse here and there, you can put all the chemical products in the storage area. Here, the storage area is restricted, so you have to have the minimum product there. And sometimes what happens, in some of these places, they have a separate port standing nearby with all these chemicals, okay, all other products they can have. Suppose you have a lot of drill pipe, casing. The casing, normally what happens, you cannot have all these drill pipe casing in the floor. So you can have a separate boat, put the casing there. Once the casing start, then the boat will come and you can pull the casing from there, then start the casing job. So the restriction in the offshore, whether it is a submersible, jack-up, or there is a restriction space there. So little space you have to work and you have to plan accordingly. But land rig space is not a constraint. You can just put things here and there. Okay. And semi-submersible achieve stability by flooding the pontoon. Same thing as you have done in submersible rigs. You have to pour some water, okay, and then you have to put the weight and lower its center of gravity. This will ensure that the platform remains stable in rough sea conditions. And everything, drilling massive punches the ocean floor, everything is there. And semi-submersible can be moved to the seabed using anchors. And in some places, what happens is a very, very deep sea where you cannot have now deep water. In a deep water, you cannot have an anchor. Now the deep water depth is, let us say, some 2,000 feet, 3,000 feet, 4,000 feet. You cannot have 3,000-4,000 feet of anchors, okay? Because it's too heavy. In some cases, they don't have an anchor. it's only the float, and they have this floating type of things. And this dynamic position system employ thruster that constantly adjusts to keep the fixed position over well based on satellite. And these are some of these positions. Unless you see this thing, they have the dynamic position system, and the system can tell you. Otherwise, what will happen? The rig will flow. You have started drilling. Now already the pipes are there and it's touching the drill floor. And in the meanwhile, supposing the rig moves, then what will happen? Everything will break. So to avoid this thing, they have the rig moves, definitely deep water rig moves, but it may move just maybe few meters here and there. So not disturb. Sometimes that's why if you see the deep water, if you're starting drilling here, you may not reach the location just below it. It may be somewhere because the current, because the undercurrent, it can move, but not move too much. For that, you need to have a dynamic positioning system. Okay. And these are deep water operations. Semi-submersibles can be operated in much deep water, like you see 10,000 feet or more, depending on the design. The semi-submerged nature provides stability on rough seas, reducing motion and ensuring safer movement. Then they can be moved from one location to another, making them suitable for exploratory drilling. So they can move for one location to another, like a normal jackup rig. Movement is same. Like a normal jackup rig or semi-submersible rig, the movement is same. Only is how you are going to position it. Are you going to position using the lag? Are you going to position using the anchor? Are you going to using the floating system? So it depends on how you are going to position this rig in a particular location. For a landing, there's no problem. You just put it on the land. But for offshore, you have to decide how you are going to fix it. Depending on the water depth, you decide whether you are going to use the legs or anchors or semi-submersible condition, submersible condition. You have to decide which condition you want. And accordingly, you have to hire the rig. There are drilling contractors are there. They have the rigs. So you have to hire the rigs and then you do the operation. Before that, you have to do the survey, find out the water depth, water current, everything, make the survey. Then you have to order the rig, then the rig comes and you can start drilling. Other drilling things are the same. Whether it's a drill pipe, drill collar, everything is same, only rigs are different. Okay. And this is a drill ship, as I told you. This is a type of you can call it a self-propelled drill ship here. So in the drill ship, the same thing. In the rigs which I have shown you in the earlier pictures are not self-propelled. You have to pull it. Here it is self-propelled. It's a ship, so you can drive the ship. Here this is the same thing. This is the same mast here as you have seen the land rig. You have the mud system here, and then you have the helipad where you have to go to the ship, and the living quarters are here below the deck, and this is the ship moving. How they run the ship captain, everything is there, so they can move the ship. And this is some Transocean is a very big company, Transocean. So they can move the ship. So here what happens, you don't need the help of a tugboat, okay? Because to move this other, you need to have tugboats. The tugboats will tie this thing and pull it. In other cases, it's not self-propelled. Since it's self-propelled, it's a ship, so you don't need the help of a tugboat. It can just move. It's like a ship, you can move. And while moving, you don't have to do anything. The whole thing can be like this, you can move it. It's not like a land rig, you have to disassemble it and reassemble it. Here it's not needed. You can move the whole ship like this. And people will be there. In onshore, what happens when the rig moves? The crew members, because you have to move the living quarters also. In such cases, the crew members have to be shifted somewhere. And also in the type of offshore rig, the jackup rig, there also the crew members are not there. Normally the crew members leave that rig and only few people are there. Those who are responsible for the jacking up, jacking down, everything. The rest of the crew members have to transport it to other place. They come back to the land. But here what happens, they can move to all the crew members, everything can move together, no problem. Their maritime vessels operate in deep water modified to include a drilling rig and special stations keeping equipment. They carry large payloads compared to semi-submersible drilling rigs. Position rig, while drilling is ongoing, is achieved with multiple and dynamic propulsion. Of course, the position rig also again depend on, of course, it's not jack-up type of here. Some are jack-up types also there. So it depends on how you are going to place the rig, whether you're going to use the buoy to take it semi-submersible, you want to jack, everything you can decide for the mast. The rest of the things are there. And they're less, so here what happens, the whole ship moves. You see what happens when you pull these other type of rig, but it's not self-propelled, you need at least 3-4 boats to pull this thing. So naturally, when 3 boats or 4 boats are there, they have to properly coordinate there. Otherwise, some boat will move there, some boat will move here. That coordination has to be needed. Here, what happens? It's less maneuverability is needed because only one ship is moving. It can move off its own and go to any location and then start the work there. Okay. And the key features are ship-like structures. Unlike semi-submersible or jack-up rigs, these ships has ship-like structures which allows them to navigate vast ocean distances without the need of tug assistance, like as a tugboat. And drilling derrick positioned at the center or slightly up center of the ship. And moon pull, this is opening in the center of the drill ship. That's called it. In other cases, because they're drill ship, you have to have an opening through which you have to lower your drill pipe, everything. Through which the drill string and riser are lowered into the ocean and through which drilling operations are conducted. It's called moon pull. Okay. Okay. So power. Okay. And here also you have the dynamic positioning system because it's a ship. It has to be a dynamic positioning system. And this system uses multiple thrusters controlled by computers which constantly adjust to ensure this remains in the over the drill locations. So it's like that then. And mobility, one of the primary advantage of drill ship is the mobility. It can be easily relocate, can move from one location to another of its own. Then you have the deep water, and these things are used in deep water drilling. Okay. In the deep water, you cannot have a jack-up type of, you cannot have a like 12,000 feet of a lag. If you have 12,000 feet of lag, the whole thing will tumble. It cannot take it. Okay. So there you cannot use the jack-up, neither you can use the semi-submersible tip. Here is the floating type of thing. So for deep water, this type of are best. And the deep water, what happens? Normally the deep water is quite far from the mainland. So what happens in that case, if you have this type of rigs, other rigs which is not self-propelled type of thing, so you have the tugboats. Tugboats cannot be there on the sea for days together. So you have to call the tugboats, they'll bring and then take it to any location. Okay, so it is easy because you are you are not dependent on others, you are independent, you can move. And the dynamic system ensures that the ship remains fixed on the drilling location despite current, wind, and waves. And this can be used for deep water, ultra deep water operations. And mobility is easy. The ships like structures allow quicker relocation. And drill ships can carry more supplies and have more payload, prolonged operational durations. You see, normally what happens, deep water locations are quite far from the mainland. So in other rigs, whatever is maybe very close to the mainland, maybe few kilometers, maybe 70, 80, 90 kilometers from the mainland. So you can send the requirement, or okay, all these chemicals, other tubulars, products, even if the crew members are staying for them, fooding items, everything you can send by a boat to this type of rig, which is not self-propelled. But here it is quite far. In these cases, you see deep water is quite far from the mainland. So sanding things become very, very difficult. It takes a lot of time. So since it's a big ship, they can have a lot of things there. And since it's floating in a jackup is standing on a lag, if you put too much load on this rig, whatever the lag can break. Here it's floating on water, so that danger is not there. You can keep a lot of things in the ship for an extended operation. And the crew members can stay, you can have all their food material items, everything's there, tubulars, chemicals, a lot of things you can keep in the rig since it's floating. I think that's the end of the introductory lecture for drilling engineers. And if you will going to attend these 3 modules classes, you can have many more discussion. I think can make it more. If you have if any question you can ask, so we can like tweak this particular presentation to satisfy your requirement when you have the regular classes. So if anybody has any question, you can just ask me, or any suggestion. If you want anything to be included here, any question in suggestion, please come up so that we'll try to make it as per your need and requirements. Yes, any question? Joseph and Thompson, there is one Jagdish Kumar. Yeah. There's no question here. Hello. Any question here? Anybody? No.
Yes, sir.
Yes.
Okay.
Yes. Azora, yeah, please.
Okay. My question is on the drill ship. I want to know during drilling how is the rig how is it configured to manage the rocking of the boats of the ship rather? How is it managed during drilling? I think tidal waves can actually cause the rig to rock. I don't know. So how is that?
Yeah. And that's what this dynamic positioning system is there. So it can take care of the rocking of these boats. Okay, rocking of the boats they can take care. Then risers. Normally you see what happens here. They use a riser in deep water. So risers are flexible type of thing, a bit flexible. It's not very like a drill pipe. It's not stiff. It's a riser. So it can take care of small movements. The risers can take care of small movements. Okay, and also you have the dynamic position system, and then you have this pontoon type of thing, so you can just take some load, and movements will be restricted. Movements will be there, but you have to minimize the movement. It will be there. You cannot stop it's not like a jack-up type of rig where it's standing on the leg. Since floating, some movement will be there, but those movements is minimized by using this dynamic position system and using the flexible risers. Okay. Correct?
Okay. And one more thing, since for deep offshore, I think the temperature of the water, from the seabed to the water table, has a way of affecting the temperature of the mud at surface. So you may not really have an ideal geothermal temperature, from the mud. I don't know if that is correct, or how is that?
Yeah, you see, there is a separate class for deep water drilling. We have a course here also in the Globat also running. There is advanced classes for deep water. As you say, is correct because the water temperature on the seabed in the deep water is around 4 degrees centigrade. Okay. But the sea surface, it's maybe around, depending on the temperature of the particular area, the locality, where maybe if you go to some Western countries, is very cold places, but you go to Africa and some Middle East countries is desert. So the atmospheric temperature is more there in those places, maybe 34, 35, 40 degrees centigrade temperature on the surface. As you go deeper and deeper, then it becomes 44 degrees centigrade. It do affects, you have to design a drilling fluid such that these thermal shock, it can take the thermal shock, no problem will be there. Design the drilling fluid, design the cement, design the completion fluids, those are different as compared to the normal well. Deep water, that problem is there. So we have a separate discussion on deep water. So here we are just concentrating on the rigs. So we cannot discuss everything on a deep water here. It's a separate class. There maybe some is a separate model for that. Okay.
Okay.
Yeah.
Okay. Thank you. All right.
Anybody else? Anything? Anything? Anybody else? Any question?
Yeah, my question. Hello.
Yeah,
Hello?
please. Who is this?
Yeah, I have a question here. For offshore drilling. What is actually the key factor that determines the type of rig to be used for drilling?
No, can you just repeat once more? What is the question? Can you just repeat? It's not very
Yeah,
clear.
the question is for offshore drilling.
Yes.
What determines the type of rig to be used? What factor determines the type of drilling rig to be used?
Okay. What factors determine the type of drilling rig? Okay.
Yeah, for offshore drilling. Yes.
For offshore, it depends. The most important factor is the water depth. It depends on the water depth. Okay. Like as you've seen in the swamp water, the water is very, very low. You can use a barge there. You don't need a very big ship type or don't need a checkup type of thing. But you see, there are 3-4 different things. One is the very damp area. Damp area means slushy type of thing, maybe few feet of water. There you cannot take a onshore rig, that's land rig. You cannot take a ship there, so you need a barge there. Now next comes a bit more deep water. Okay, in that case, it's really putting such a ship there is expensive, so you can have a jack-up type where you can the rig can stand on its leg. 3 legs are there, stands on it. But as the water depth increases, so naturally what happens, these legs cannot, if you like, you cannot have a like 2,000 feet or 3,000 feet of leg. If you have that long a leg, then it cannot take the weight because of center of gravity will go up. So it might tumble, it can tilt. So you cannot have a jack-up there. So for a jack-up, a certain water depth is required, minimum water depth. Again, as you go a much water depth, their jack-up will not work. There you need to have a floater type of things where, and in some cases, between this floater and jack-up, there is another place where you can have the anchors. Okay, there the leg will not work, but the anchors, the anchors chain can work. So depending on these, how you decide, and the rigs are available, so you can decide. So you can have like 4 types of things. Minimum, you can have a barge, then you can have a jack, then you can have the anchors, then you have the float. So the water depth only decides what rig you are going to use, and the location of this place where you're going to drill. It's very far from the land, then it's better to have a ship there. It's near the land. You can sometimes, if supposing, of course, you cannot have a very deep water near the land because this continent itself is there. So naturally, these deep water locations are quite far from the mainland. So there is better to have a ship. So self-contained type of thing, right? Is it okay? Yes.
Okay by me.
Yeah. It's okay.
Hello.
Yes, somebody else is asking a question, please.
Sir, I am Jagdish Kumar.
Hello? Oh, Jagdish Kumar. Yes. Yeah, you are from?
Yes. I'm from Bangladesh, sir.
Bangladesh. Okay.
I'm from Bangladesh, sir. Bangladesh, sir.
Okay,
sir,
you are working.
Question.
Yeah, please.
You said?
Yeah, please.
Hello?
Yeah. You
Sir,
continue
I have
with
a
the
question.
question. Please.
What what is the advantage of top drive system instead of Kelly drive system? In lieu of Kelly drive system. What is the advantage of top drive system, sir?
Prop drive system, yes.
Top drive instead of Kelly drive system.
Yeah, correct. There are different things there. As I told you, the 3 drives. The question is how you are going to rotate the bit. Okay, so either you can rotate your table, or you can have a top drive, or you can have a mud motors. So normally what happens for a Kelly drive, you need a Kelly with Kelly rotates. Okay, and then the table rotates. So you see the energy loss is more in a Kelly drive as compared to top drive and the mud motors. And mud motors is normally used if you are going to drill a deviated well. So there the whole drill string is static, only the bit rotates. Here what if you are going to rotate the whole drill string, there's a lot of energy there. So it's a question of loss of energy as compared to the Kelly drive. The top drive, you loss the loss of energy is less, and the loss of a lesser is you go to the mud motors. Only thing is question of the loss of energy, when the energy is transmitted from the rotation back to the bit. Okay, and sometimes what happens, if you are going to drill a very tough formation, very hard formation, in that case it's better to use the top drive instead of using the Kelly drive or the mud motors. Okay.
Okay, thank you, sir.
Anybody else? Okay, so I think we can stop it here. So you can you listen to this thing, so it's okay. We can, if you are interested, you can continue with other 2 modules, more classes. This is just introductory class. So it's up to you. You decide what you want. And if, of course, this Globat people will decide when to start the regular classes, depending on the number of the students they join on a regular basis. So let me say goodbye to all of you, and maybe if some of will join these classes, regular classes, we can meet in some other day with some different topic. Okay, thank you.
All right, thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Okay,
Thank
bye.
you, sir.
Thank you, Dr. Sikrant.
Okay, thank you.
Thank you, sir.
Yeah. Hello, guys. Thank you very much for joining the class today. Please leave your names. I'll give you another 2 minutes to leave your names and your email in the chat box here on the Zoom call. If you require a certificate for this course, I trust that you all are on the WhatsApp group. You can send a private message to any of the admins or me directly if you want a certificate for this. Also, if you want a certificate for this course, you would need to take the quiz or test. That is what would guarantee getting a certificate. The certificate is not free. It's not free. So, but please leave your names and your emails here for attendance so that we can send you a certificate of attendance. Thank you, and call it a day. Yeah. All right.